I don't know about that. We were talking about in the parking lots.
Math, 6 through 12, October 2nd, here.
That parking lot down there.
Firewalls, anything, so you have to be careful about that, but schools are not, probably not university. I think everybody is back, is that right? Are we missing anybody?
Just for your information, the $69 one is called, sorry, this is important stuff.
It
It's
is.
important stuff.
Yes.
It's called Point to View,
Point to,
yes. And it's the $69 one, and it is super. And then you can buy the accessories to go with it, the little case and the extension on it.
so do we have everybody back? Okay, so I guess we'll go ahead and get ready to start. Do you need some nutrition? Okay, so let's go ahead and, I think we ended up finishing up everything on 6th grade except for looking at number. So I guess that's where we'll start now. So if we can pull that up and maybe start our discussion there, that would be great.
For me, once again, it's going to depend on what the 5th grade's doing to segue into it.
Very nice one.
That's where I am. I do think it's important that we make sure that the solid foundation of fractions is finished up. So whatever they don't do in 5th grade, I think that to me is so important.
Because if I'm not mistaken, I believe in the Common Core document right now, what people are supposed to be teaching to is that everything except revision of a fraction by fraction is supposed to be done by the end of 5th grade. And in 5th grade, isn't it fractions divided by fractions and everything else prior to that is supposed to have been done? Is that correct?
I believe that's right.
I think so. We're still in the trickle up effect.
Right.
So
Well,
of
look,
course,
if you no matter what we
yeah,
do, we always
exactly. You're going to have a few years.
That's what's supposed to have been done, but there's not. Yeah. Okay, so fractions, we want to make sure that whatever is not finished in 5th grade, that we make sure that that is done and done well in 6th grade.
And I guess one of the other things that is big there is starting the idea of positive and negative numbers. We already talked about it on the 40th grid, but really developing a sense of what that is and how they're positioned and you know, everything about that, absolute value,
Yeah.
distance from 0, etc.
Rather than teaching just memorization, really teaching, really understanding what positive and negative is.
Well, even really understanding what absolute value is. I mean,
Yes.
I don't know how many years you have to teach it, but no, it is not just automatically positive. Or,
It
you
is.
know,
It's
well,
not.
you know what I mean. They
Exactly.
opposite, that's the word that I was looking
Yeah.
for, because they always think it's the opposite.
Right.
And you're like, no.
Because we don't teach it very well, the definition and conceptual understanding of that. It's, again, it's another thing we've memorized, and they don't really understand it.
I do like that they mention number theory, you know, breaks common factor, leaves common multiple, etc. Here in and 8 is where I was specifically looking.
And I really like those divisibility rules that they mentioned also, but I can't get kids to use them.
Do you make them do 7s again?
No. I don't,
That was a real quick no.
I honestly, I'm like, just divide it for 7s. And I don't make them do 8s most of the time either, because I'm just thrilled if I can get them to do 3s. They will not use the divisibility rule.
I think those things are really pretty important.
I agree.
Prime factorization is super important.
And that's one thing that I think is,
go on to factoring.
Yeah.
I think that's only,
Yeah.
I think that's only currently in 6th grade right now.
Yeah,
And that's the only
interesting.
time that I see it, and I really.
Well, and if it's really spent a lot of time on development of it, fine, but I don't think enough time is spent on it. And again, I think it goes back to a lot of memorization of facts as opposed to understanding.
Which I think we'll get to more time when it trickles up, I mean, when other things
Yeah.
move.
Well, my concern with it is if we teach it in 6th grade, we all know that kids, if you don't move, if And if you teach it in 6th grade and then you don't teach it again until algebra when you're factoring trinomials and they've never found the GCF or LCM of monomials, then, I mean, like in our district, we teach it again anyway because we think it's important to keep
Sure.
that going, but I don't think everybody will. If they don't teach it again until algebra, you're gonna have to go back and reteach a lot of it because they're not gonna remember.
And that goes back to curriculum, I have to.
Oh, no, yeah, I mean, I think that is something that we really have to think about, and I don't think anybody probably disagrees, but, you know, sometimes kids do get away with things, and I do still teach algebra too, and I tell kids right at the first of the year, you know, a lot of the stuff that, you know, if you've been, I'm nice, I'm really trying to be nice, but, you know, if you've been, you know, sort of getting away with not knowing these things, you know, and you sort of lived through algebra 1, you know, right here, this class is where you're really gonna pay a toll for being slow, for being just not getting it, and so that, I don't think we can say enough that the fraction and some of those little number rules that, even stuff that kids think is cool, like the little line thing that you do with your hand, that I forgot how it goes.
The multiplication thing,
Yeah, you.
9 times 2 is 18.
Yeah,
9
that's.
times 3 is 20.
that kind of
That's what it is, yeah, and I think kids like those things, and I mean, I'm not a warm and fuzzy person, I don't necessarily like kitty things, but I like those things.
I like those things, and I like the kids at the high schools come and prove it, why is it work?
Yeah,
They, you know, that's the next step, okay, you can use it if you can prove it. So, yeah,
that's great.
I guess my question is, do we need to make sure and put in factoring in monomials, or
are you talking about that,
or is that?
that would be after 6th grade, that would
Right.
not be,
Yeah.
so I'm not gonna disagree with that, but I don't think that's probably 6th grade because of losing it.
No, I don't think it's 6th grade
Yeah.
either.
So, but that's a good point to bring up, because when you jump from here and then you jump to trinomials, then yeah, that is a big jump, so,
I see it as part of the distributed property, maybe coming later in the
Yeah.
school. You know,
Yeah.
pulling out the 3x and still
Right.
having y plus 2 half.
right.
It's a good place to be.
It is a good place.
I do have a little problem with 6 and 10, where we are doing operations with positives and negatives. I think that we just need a good foundation and what are positive and negatives, where do we position them, what are the absolute values, things like that.
So number line important grid.
And I think that the issue will also have to be, then we are gonna have to be careful about solving one-step equations to make sure that we don't use positive and negatives in there, because those correlate, if we're gonna just do one step, and we haven't done addition and subtraction of positive and negative numbers.
I think at any grade level, you have to consider what the
Right,
set of numbers you're
yeah.
working with.
yeah, and so, but that would be one thing in the document that people don't realize, these are the sets of numbers you're working with, so when you're solving equations, these are the sets of numbers that you should be dealing with. Good points, because I agree with you, I think that's too much.
And along with the positive and negatives, also what a negative number means in a real world kind of
Mhm, in
situation.
context.
They do not get that very well.
Well, that's easy, that's what my son has left over money after.
Yeah.
And
But does he really understand that?
when teaching integers, if you can't put it in terms of money, they look at you cross-eyed, but if you can put it in terms of money, they can get it.
Well, I think this isn't what it seems to me, and again, I've never taught middle school, but it seems to me that that's where some of that, you know, just memorize the rule comes from, is because, you know, they just don't understand it, and, you know, is, in some cases, I think it is because they're not ready. I think we have kids, you know, that just can't do algebra 1 in 8th grade, in my district, we put them all in there. But some of them do so, you know, and so then they just don't make it through the 8th grade year, but then they do so well that they're in honors later, because they're so good and they get it. And people ask me sometimes, you know, how does that happen? I don't know, maybe they have a personal problem, but a lot of it is probably just mental maturity, being a little bit older. And so if that's where, so I like what I'm hearing with these kinds of things, you know, to move them until the kids are ready, and then it's not going to be so painful, and then they don't have to resort to those, you know, just memorize it and don't think about it, and then you have to move on.
And I think a lot of teachers teach it from memorization of rules rather than using manipulatives to help the kids formulate the rules and understanding, so they have that to go back to.
You know, I know there have been a lot of parent nightmares out there about Common Core and explaining themselves stuff and stuff, but I would teach that to the kids even for math tests, because I knew that they'd get a point for showing, however you do it, I'm not saying you have to do it my way, but showing it,
Right.
and a point for correct answer. So I would ask my kiddos, you know, how'd you get that answer? Well, if a good guy comes to town and another good guy comes to town, then that's a good thing. But if a bad guy comes to town and another bad guy, or a bad guy leaves town, then that's a good thing. And I said, what are you doing? I said, you are not going to leave my class and explain it. You are not doing this. Well, you don't, and this is kind of funny because I had sort of been her mentor years ago, the regular 7th grade teacher. I think Michelle knows a little bit more about math than you do. And I said, well, I appreciate your point of view, but you're not doing that. Because then we'd start adding numbers.
Right.
And those same good guys would have the same rules. And the same bad guys, because they didn't connect it to the operation. It was just about good guys and bad guys coming to town.
Right.
Carrie saw me when she said, I hear I can't do good guy. I said, you can do whatever you want, but don't explain it to me.
It's kind of like the alligator and the inequality sign.
Yes.
Eats the alligator.
I really didn't mind that as much.
I think we want to be sort of cognizant of the fact that, you know, that there are lots of strategies, and we want to, I think we can say that we support, you know, the conceptual development for kids, and obviously, you know, I think that's I think what I'm hearing, it sounds like we're all pretty supportive of that idea, but without being too prescriptive to the teachers, because I know that, you know, some of the things, you know, might be appropriate, or appropriate maybe is not the right word, but might be helpful for one kid and not so much for a different kid. And so I think if we, you know, that's part of the professional judgment, you know, that teachers, you know, should exercise and should feel empowered to exercise. It should be, you know, it should be a fun job to have, and that's one of the, I think, fun parts of it is that, you know, that I'm making those human decisions every day.
And Julie, to go along with that, although I wouldn't want them to explain this way on a piece of paper, one of the best teachers I've ever met in my life explained most everything she did through songs.
Yeah.
But I don't expect the kids to write songs, you know, but it helped those kids remember stuff, you know, so I agree.
That's always the danger though, in a set of standards, when you try to explain too much, is that you're becoming too prescriptive. And so, and I think there are definitely times in Common Core where I think they've gotten a little too prescriptive.
Sure.
We're talking about like
We have one coming up in 8th grade
trying
that I
to
think
slow,
is,
I think it's way too prescriptive. It doesn't need to be there. So
And
it's not that the standard is bad; it's the explanation.
And I think sometimes, yeah, exactly that, the explanation, and that you even get into that sometimes when you write an example problem.
Yeah.
Because then
Everybody thinks that's it.
that's the only thing I have to do. And so it's kind of like you try to be helpful, and when sometimes when you try to be helpful, you actually cause more confusion.
Yeah.
So.
one other thing that I noticed on here that I think will help people a little bit, it's not that it was omitted, but they maybe had to read a little bit in the Common Core to get it, and maybe we could put it out there more clearly, is that they never really saw the conversion from fraction to decimal to percent clearly.
Yeah, I agree.
And percents are introduced under ratios and proportions in the current standards we have in the Missouri Running Standards Common Core.
Right.
But we may want to make sure that we do make that very clear where it is. And then I think decimals or converting to a fraction to a decimal might come a little later.
Fractions to decimal using non-division is in
7th grade. Because they go along with the more fractions stuff where they're doing the unit rates and fractions and things like that.
One of the things that I really liked about this document, you know, we had talked about verbiage and things like that earlier. We talked about the word fluently last time, when we were fluently computing different things. Well, this uses the term accurately and efficiently, and I like that word better if it's something that we would use for.
And I agree, because I like accurate, efficient. I don't like fluent because there's so many different definitions of fluent, unless we're going to specifically define what fluency means. Because right now, it's all over the page as to what it means, defined by, and it's more defined, I think, by books than it is anything else. What I'm seeing right now is going out to different districts and everybody's doing timed tests. And in one district, they have to get this many done in a minute, and another district to be fluent, they have to get this many done in a minute. And is that really our definition of fluency?
Well, and that was a question I was gonna have. I like the accurately, I don't know about the efficiently, because different kids have different ways of coming at a problem. It's the way that they understand it, they get it. So what's efficient to me
That's true.
may not be efficient, but I love the accurately. And I understand the need to, maybe get away from fluently.
Yeah.
I'd like us to think about efficiently though, because of the kids that just take a little bit longer to process,
That's why I
or
don't like
maybe
timed
do it a
tests.
different way.
That's why I don't like timed tests, because the kids need more time to figure it out, and if they figure it out, so be it.
And sometimes the methods that we see, instead of being related to the standard and Common Core, I think are the resources.
Oh,
I think it's what people have put in books. Or,
There's some crazy stuff out there.
you know, and unfortunately, sometimes they're covered page by page.
Yeah, go ahead, Ian.
I wanna speak up for efficiently.
Okay, go ahead.
I think ultimately your goal in math would be efficiency. Now, I realize we are talking about teaching kids, but
Right.
ultimately you want efficient methods of solving your math problems, because that enables you to do the more complex problems and not have to spend so much time on the basic math within those complex problems. I think there's a lot of people out there who are concerned that there's such a heavy emphasis on concept teaching in Common Core with all the drawings and all that stuff, that it makes the basic math less efficient. And if we don't move them off of that at some point and get them moving towards efficient methods of solving the problem. So I would hate to see us just abandon efficiency.
Well, you know what, and when I used to travel around and do professional development in different districts and things around the state. And sometimes the participants would get up and they would share what they loved. And the methods that they would share that I just avoided. I thought, what are you doing? And I still don't. I don't like the lattice method. I don't like it. I don't like it. I don't like it. My kids would come though from into my 6th grade class, and if I would ask them to do something, they'd start drawing this box, and I'd say, by the time you get the box drawn, I can do the problem, you know, or John can, or Susan, or whoever, but and then I try to think, if they get it that way, should I try to move on from it? And I think that's where I was, because I said, guys, number one, at some point, there's some things you just need to memorize. You need to sit your little self down and you need to memorize some facts. And it's after you understand that it's an array and you can count this many rows of this many things, eventually get yourself to the point where you say, 6 times 7 is 42. I don't have to chisel it out.
But they're gonna have to take,
And I
so
think
I agree, as long as they just time, they're still gonna have to know it quickly. If you have the ACT, they're gonna have, and yeah, if you're laboring still over drawing something out, what's 6 times 7?
Well,
Then
and I think it's like you talk about by a certain time, you should be able to do it with automaticity. You know, I like, that, like what Nancy said, I should know what 6 times 7 is, I shouldn't have to be counting on it. I think in the first year or two, when they're really developing those, efficient is a good thing to say, but by the time they're in high school, by God, you better know.
well, and you have to
Yeah.
understand that some of us are coming from districts that we have sat with superintendents and administrators that have told us we're a nation of cell phones and calculators. It was a waste of brain power to memorize your multiplication tables. That has been said.
It has been said, but I think you were here last time, but when I started teaching VC, which is before calculators, and the kids couldn't do multiplication. My freshman year, my class was teaching them the multiplication facts back then. So I agree with you, the kids sometimes become dependent on that. The way I controlled that in my classroom is I had a 2-part test, 1 part no calculator, 1 part with a calculator.
We have that.
So, I can control that, and teachers can have the control of that, where they really need to use the problem solving skills that I don't care if they know their multiplication facts, I know they can problem solve, I want them to have a calculator. With some of the other facts, no, and I think that can be
Well,
controlled.
it's complicated to do algebra if you don't know.
Yes.
Absolutely,
The
That's-
very
we
basic
totally
building
agree.
blocks.
We absolutely
And so,
agree.
But
Yeah,
I think
disagree
those
with it.
things always have to be memorized at a
earlier age than even fifth grade as far as the multiplication and addition facts still. I think it's easier, even grade applies.
The problem with the word efficient is it's relative, because
Right.
there are times when it is much more efficient to use a calculator.
Right.
There are times when it's not efficient to use a calculator.
Yeah.
I mean, there are good times to use it and bad times to use it. You know, if you're doing 3 plus 5, you have to use a calculator, that's not efficient.
No.
It's not, and some students do that, so, I mean, I kinda agree with you in terms of, I'm not
That's
sure if I.
twice.
I know, it's weird, I know, but it's kinda hard for me to talk about efficiently, because I think efficient is relative to the situation, and it's relative to the person, kinda like you're talking about. For some people, one technique is more efficient than another one, so.
But I don't think it is prescribing the technique
Right.
that leads to the efficiency. The point is that they are efficient in whatever method that they
Yeah.
are using. So again, it goes back to what you're talking about, which is the freedom that the teacher has. So if you time, I mean, not that we want to time the kid, but if you time the kid and say, do it the lattice, do it the traditional, and they're faster lattice,
Go
that's
for it.
their efficient method.
You know, I think about it, I'm just trying to make sure that we're choosing the right words, and if
Yeah,
that's the right word for us, that's the right word. You know, if we're, talking about probabilities of rolling to die and what the sum's going to be, and sometimes people want to reduce or put in those terms, that may not be efficient for what you end up using that knowledge for. So that's not efficient. The other thing that I think about is reducing or simplifying fractions, whether they have variables in them or not. Some kids may take, what do you think, 72 over 100, and it may take them a couple reductions, you know, to get there. That's okay with me. So I want us to make sure that we choose a word that all teachers will know, that gets you to the end and what it's for without penalizing.
Efficiently doesn't necessarily mean fastest. I mean, it
Yeah.
doesn't necessarily mean, or it doesn't mean there's an arbitrary fast time that you have to do it necessarily.
So I wrote it down as something we have to be cautious of, choose the right word.
Yeah.
And then when we get there, we'll.
Because I think we all agree with what you're saying, you know, and like, not to prescribe which method, but what we need to be clear about what is efficient. And do we want our kids to know their facts? There's not a single person here sitting in this room that doesn't think that that's important. So.
Well, I wish you could have come to my meeting then.
I'm
They
glad
took
you are.
away our down, they took away our flashcard, they took away everything. So
Stop it.
there's no more of that.
I don't know about your area, but like within an hour radius of where I teach, everyone I've talked to that gives an employment test, they cannot use a calculator on an employment test. And any certification test, I don't care if you're going for your CNA or you're going for your CPA, there are no calculators allowed on any of those tests that I've found so far. So that might be some reason they keep some of them in there is, that's great through school, but eventually they may face that test, whatever it is, and if they haven't seen those rules, so.
Well, they backed out of that because they saw what it did to our kids. Unfortunately, my kid was in 3rd and 4th grade, but they backed it out and said, you know what, actually, I think they do need to know their facts.
Well, and part of it is documentation never said don't know them. I think they said de-emphasize the amount of time that you spend on it, because that's not the only thing we want.
Because there are things we don't teach now. When I was in school, I had to learn how to take a square root in hand.
And I can still do
There's
it.
no reason to ever do that. Why?
Kathy can still do it.
I can still
I
do it.
couldn't do it. I used to have to, I mean, in
You had your
trigonometry,
story. You had your story.
trigonometry, we had these huge trig tables and we had to learn how to interpolate.
Yes.
Okay, there's no reason to do that anymore. So there are things that technology makes it much more efficient.
Right.
It doesn't mean that you still have to understand what you're doing. It doesn't help you in that way. But, you know,
Julian and Dan.
Well, no, and that would go right into the story I was telling you earlier, but, you know, again, this is a caution, because this is, you know, it's not the district where I teach, it's the district where my 7th graders used to go. And, you know, their view, and they had it in the Common Core book that they bought, it said, Common Core right on the cover, bought workbooks for all the kids. And this was it was a cockamamie method of finding square roots.
No, it was again, you.
Can you spell that for us?
But, you know, but this was, you know, the teacher was acting in good faith. She thought that Common Core required her to do this in that way, and it was when my daughter came to me and said, really, you mean it's always a 5 in the third? And I said, no, and engaged, and I tried, but, so this is why you have to be clear with your standards, is because humans are, we are what we are, and so people see things that are not there, they see things that they wanna see,
And then
and we
text,
have to be really super careful about that, cause I don't know, for my daughter, it was almost worse that I got involved and corrected it, but the reality is that, she's that kind of kid. A lot of kids are like, oh, whatever, we don't care. This daughter, not my other 3, but this daughter is not like that. If she's taught, she wants to understand things.
Sure.
That's just who she is. You gotta be appropriate for kids like that, so.
Dave, you had something.
Yeah, the last one, number 16 there,
Yeah.
I don't know how to get the right amount of emphasis on that, but when I'm working with the career ed students, they'll punch stuff in the calculator and they write it down, even if it's ridiculous. And kind of related to what Bob was saying a few minutes ago, using the technology to make things efficient or whatever our word is gonna be.
It's kind of like asking kids, like, you're gonna take so many kids per bus, how many buses do you need? And they'll say 2.75 buses, that's not reasonable. They have to know that it's gonna be 3 buses. I always ask them, which quarter of the bus are you right now? So it's not reasonable. So the kids do have to understand that as well. So that is important. I don't think we can emphasize that enough, that it's really important. Coming back to 14, one of the things that was on here I really like about accuracy, I don't really like the word simplification of fractions. That word simplify is kind of what Nancy brought up, brings a lot of things about complications, because what is simplify? Because when I think Julie and I were having some conversations, simplify and calculus, I didn't want to simplify.
Right, simplify means, well, you have to know what you're going to do next,
Yeah.
and then you know what you're,
Right.
you see that a lot.
Yeah, and so the word simplify is very confusing, so I'm hoping that we don't use that terminology, because your simplification and my simplification may be 2 totally different things and used for different purposes. So again, one of those words that we need to be careful about. I really like one of the things that is using equivalence, find equivalent fractions, find equivalencies, equivalent expressions, those kinds of things, because then they do have to know all the various forms. But simplify can be a really word that causes a lot of confusion.
And I do
Yes,
think,
there you go.
I do think in the current standards that we use, it's more like that. Everything, you're not always writing things in lowest terms, you're not always, it says equivalent more often.
And that's from here, I think that's a change. I think that's gonna shift in the way our verbiage has, kind of like what Bob was talking about from the year 2000, realizing that some of those terms like simplify and reduce cause confusion, that there's other terminology that we can use that's better, that will hopefully clarify those situations.
The last thing is, I don't disagree with number 9, but I think I'd like to, if we use it, massage it quite a bit in the language, because it's a heavy little sentence there.
Yeah, that's one of the some of the things.
Select and use appropriate operations to solve problems involving addition, subtraction, multiplication, division, and positive integer exponents with whole numbers and with positive fractions, mixed numbers, decimals, and percents. Hello.
That's about 3 or 4 standards in one.
So, I'm not disagreeing with it, just any modification I would look at. Some of the earlier ones up here, by the way, I'm thinking that those are the 5th grade standards.
Probably so.
Right, that's what they did when I looked at the
Don't you think?
5th and 7th, that's largely what they did, is just, and in some cases, partial standards,
Yes.
but,
Yeah.
do you think though, that 6 and 9 is a throwback to when problems meant word problems?
I think so.
Is
I
that-
think so too,
Is that what we're,
It could be.
I mean,
like an
'cause
application problem.
Right.
I agree, that's pretty open
Yeah.
to interpretation question, I wonder if that's what they meant.
Might have been their intent.
And,
It's confusing to me, I don't know what it's saying.
I had to reread it.
Those big.
We
big
want whole
sentences.
number exponents, but the basis can be positive fractions. Mixed
No.
numbers. Is that not what it's saying?
I don't think so.
Okay, see, I don't understand it. What
I
is it
think
saying?
it's saying that you're gonna do addition, subtraction, multiplication, division, and positive integer exponents with whole numbers.
Gotcha.
And you're gonna do those same operations with positive fractions, mixed numbers, decimals, and percents.
That's a weird standard,
That's why I think we need to just kind of,
Yeah.
very weird.
Yeah,
because
there's a
I'm
lot.
not diagramming that sentence, it's not gonna do that.
Cause I think I could definitely, I misinterpreted that. So.
Yeah.
Okay,
Anything else?
I mean, that's pretty well was documented.
Right, is there anything else, Jill?
I'll just make one more comment, because I always think that I'm a pretty decent wordsmith, at least at times. And so, I just, was thinking about the word efficiently, and there's no obvious, better synonym to me than that. However, I do think some clarifications, because I get what Nancy is saying, that at least, and I think Kathy too, that, those mad minutes, if they're coming back, I'm sorry to hear it. I was glad when they went away. I do think kids need to know their facts. If they don't, they're gonna pay for it big time. Number two, I've said that. That's a huge issue. At some point, kids do have to recognize, that as one of my old good students told me, he was a very good student. Said, I didn't learn my times tables when I was supposed to, but then when I was in 7th grade, I realized, for example, that, 8 times 9 was always going to be 72. And I just thought, well, you know what? That's great. He was a great student.
At least he
graduated from engineering school in May, like a 4.0. So, but I mean, that's, I don't necessarily care when it happens as long as it happens. But I don't think that mad minute, do you know what I mean? Do all these, I don't think that's what we.
For him, it wouldn't have.
For him, it wouldn't.
No.
Yeah, no, and he didn't need it. So, yeah.
We went from not memorizing them to rocket math, which is the same. I mean, we have.
Right, exactly, so it's like having some common sense, and I don't know how we can stop people.
No,
They're gonna
it's
do what
local,
they wanna
local
do.
control.
Do they do mad minute and reading?
Right.
And reading big words like in the minutes?
I'm on the school.
Is there really?
I'm sorry.
I think there was a bad. What's wrong with I can't,
So are we finished with looking at, through 6th grade for, Massachusetts?
Was there anything significantly different in the, I know you said they basically broke out the grades this way for NCLB.
Right, right.
Do they keep them exactly? Yeah.
They didn't
Something-
add, I think they added, I think they broke it apart.
Right, so
They took some,
there's nothing.
because some of them it said same as the standard, and sometimes when you went through and reflected, but I didn't notice anything new added in, maybe because it was separated out somewhat.
Yeah, no, it's not, in some cases, they just did like the first 6 and then just left off like,
And they did that because we went from a grade 10 test to a grade level test, and so try to stay within what they're doing, and I can understand that, it was a lot less work than rewrite the whole thing.
Right, right, I was just wondering if they had, if anybody knows.
I guess I need to say what I said last time I called before, because it's in here too. I mean, there's a whole section before the actual standards where they talk about
Right,
the principles and
right,
the
yeah, they do.
problem solving. It's very similar to the standards for mathematical practice, except actually, I don't know if they quoted them, but it's word for word on NCTM principal standard.
Yeah, it
It's exactly the page. I mean, I remember the
Yeah.
book, and it's the pages even almost exactly. So,
It's from the principals. and-
but the idea is that and it says right at the beginning, it's more than just these standards. It's
Yes,
teaching students to think about how to think about mathematics and the
Right.
practices they use in doing that. So
right,
I know we said that about the Common Core, but I want to say it's in here too.
because I think that's important that we have in our document, where, because if we can only get our kids to think about and be problem solvers and reason and construct viable arguments and those types of things that are in the
Use
practice.
tools appropriately. and
Yeah, use
just talk
appro-
about
That's one of my favorite ones, we
Yeah.
talked about that, there's also goes to David's question or comment
Yeah.
earlier about the approximations and
Right.
recognizing
Yeah, so I think those have to be a piece of whatever we do, whether we use exactly what's in the Common Core, whether we use the principles and standards. I don't think it matters. I think we have to have something that says those are the important things that we value in all of our kids to be able to do. Because even kids that may have computation errors maybe can't compute, have really good computational skills, can still be good problem solvers. I had a young lady in my trade class one year that was told not to continue in math because in Algebra 2 they did not allow her to use a calculator. She had a D or an F. I said, come on into trade and we'll see how it goes. She had a calculator. She was one of my better students because she was a heck of a problem solver. She had a lot of trouble with calculations, but she was a heck of a problem solver. So she would not have gone on if we hadn't given her that tool. So she could problem solve even though she struggled in many areas. So that's one thing we want to make sure all of our kids are able to do is be good problem solvers.
Bob left, I think, several years ago.
I know.
I taught middle school for so long, and I was going to be a teacher in a math academy in the summer for high school teachers. So I went back and took a trig class and a pre-calc class, and I enrolled, and I'm certified up through 12th grade.
Did you say you're certified?
You're certified, you know? And the instructor said, I really don't think that you're qualified to be in here. She said, I said, well, I have a degree and I've taught algebra all these years. I'm just trying to refresh on comics, on this, on that. Of course, she never got to those. But yeah, she told me that. And I said, well, I have the permission of the department. But I thought, that's one of those kids that was told, stop.
That's so,
But I did this.
that's so, and, you know, and it is true, and I don't wanna, get into some of the stuff, before the time, but, we do have to recognize that, as important as fluency with math facts and things are, the reality is that technology is here to stay. And, we are going to be using, computer algebra systems and things like that, and the sort of stick-to-itiveness, whatever you want to call it, those are the skills that, kids really need, and so.
Well, and quite honestly, we're looking at a world of big data, and your statistics stuff is actually, it's gonna come out of the closet.
Yeah.
Because that's all they're doing is.
Right. I think we have to be careful. Sometimes we're teaching for the old and not teaching to get kids ready and prepared for the future. Nobody's arguing that they need to know the facts and the basic facts. However, there's so much more that we need to be doing with our kids to get them ready, to be problem solvers, to be thinkers. Because like somebody said, the kids today are the ones that are going to run the nursing homes that we're in eventually. So we want to make sure they're well educated. So anyhow, so are we ready to move on to 7th and 8th grade Massachusetts? Shall we try to see if we can get that cranked out this afternoon? Or do you have what?
We were gonna do 7th and 8th Massachusetts and Common Core kind of.
Comment, yeah, okay. Sounds good.
And
We were also
actually,
doing,
we kind of did that.
yeah, we kind of ended up doing that anyhow, so sounds good to me.
Yeah, 5th grade Common Core on the agenda also.
Because last time
Darn.
it was mentioned that we kind of needed to know where
What was going.
the 5th graders are coming from here too, since they're looking.
I
I'm
asked
trying
that
to go
group,
with Massachusetts and
I asked that group, and they said that they kind of outlined big, I'll call them domains, for lack of a better
For
word.
5th grade, for K-5?
For 5th grade, yeah. And that they had maybe even talked about some clusters, but they hadn't gotten down to standards yet. So I thought maybe we could put 5th grade on the back burner until we.
Okay,
I'm good with
and
that.
one of the things that I think some of them said this morning is they want to know, they would like to know by the end of the day tomorrow, because they're starting to look really more seriously at 5th grade. If there's something from 5th grade that has moved or shifted that we think really needs to be done, so we need to give them some direction, because they're gonna start with 5th grade and work down. And so we need to, by the end of the day tomorrow, give them some direction of where we think our starting
If they
points.
meet, they gotta make core meetings, so.
Okay, so,
Yeah, they're not meeting.
okay, well, but if they do, that's, by the end, that's what I think they said, by the end of the day tomorrow, they would like to start from there, so. So, shall we then hold off 5th grade until, tomorrow and start with, we did 6th grade, and look at 7th and 8th grade, is that all right for people to go through and do? Okay, so we're just gonna kind of do them side by side. Do we want to look at Massachusetts and then go back and forth, or how would you like to proceed from there?
That's fine, yeah.
I remember Massachusetts.
Okay, let's do it.
setup, I mean, of talking about how we're developing our standards. I like the setup of Common Core in that on the first page of the document, it kind of gives you like the main, first of all, gives you the focus areas, which I think is really important as a teacher, because ideally, yes, I cover all of those things in 1 year, but when you have 55 snow days and this and that and the other, you need to know where to focus your real world stuff. I mean, you need to know where to focus your efforts the most if you have to cut things out. So I really like the focus areas at the beginning, but I also like just the number system, this is what I'm doing, and expressions and equations, and then how it gets in more in depth later.
So kind of like, here's
So
the
like that
big,
format.
here's the big three key concept,
Yes.
things to focus on. Here are the
One
basic,
is straight.
yeah, a couple of whatever it's called, and then here are the details.
All the way up to 8th grade, I do think it's important to go back to those NCPM type focal points
Yeah, I agree.
and say these are major concepts and.
Right.
Yeah.
I think that helps
It's very
teachers focus when you, especially for a first year teacher, when they come in to look at that document, say, okay, these are the primary focus areas for the year.
And there's other stuff they're gonna teach, but try to
Right.
connect them
To these areas, yeah, I think that's a good point.
The Massachusetts, which one is it? Number sense and operations, where it says 8 and 9. So this is still chunked, right? 7th and 8th.
Page 62, correct.
Um,
I got the page number 62.
Yes, it is 62. Yes, ma'am. Compare, order, estimate, and translate among integers, fractions, and mixed numbers. Would that be more 7th? Don't you think? I mean, I know that they're chunked here, so.
Probably so.
Yeah, 7N1 says compare, order, estimate, and translate among integers, fractions, and mixed numbers. For example, rational numbers, decimals, and percent.
Yeah.
The
and-
standard is intentionally the same as standard 8N1.
Yeah, so I think that's appropriate to be a 7th grade. Yeah, I think it is.
One of the things I noticed real quick about, of course, the Common Core has different titles or subtopics, whatever. Ratio of proportion is a big deal
That's huge.
in Common Core. I have to search for it here. I mean, 8 in 3,
And it's actually though in 7N2.
Yeah, 7N2.
7 in 2.
Yeah.
Okay.
If you go to the supplement, then we divide it out.
Right,
yeah.
And ratios and proportional reasoning is a huge topic to really get covered and covered well before they start addressing algebra. Because I know kids are really still struggling with that when they come into algebra.
Yeah, and I mean, this is just personal for me. The Common Core, working with this the last couple of years, has helped me really think more about ratio and proportion in a variety of ways. Because, I mean, I think most teachers think when they first think about ratio and proportion, use ratio and proportion in the solution of problems, in particular problems involving unit rates, scale factors, and rate of change. And I kind of know what that is. But then when I look at Common Core, it talks about tables and graphing, verbal descriptions, equations. It makes me think a lot more about what I should probably consider in terms of helping students understand ratio and proportion. Not that I didn't know those things, but I mean the fact that they're all delineated under 7 RP2 there, there's an A, B, C, and a D, I think that's a valuable thing.
That's condensed so that you can see there everything that you need to do.
It's just more
I think
detailed.
Yeah, it is. I think the Common Core document does a better job in detailing ratios and proportional reasoning, but
And it's not too prescriptive or towards a curriculum to get to that level of
I don't
detail.
think it tells you exactly how to do it, but it talks about different representations that students should be looking at. So I think you can do that in lots of different ways and in lots of different contexts.
And when you're writing your district curriculum, it's really easy to just look at the standards and say, oh yeah, we do that with such and such. But when it's more detailed like this, it makes me think, oh, but do I do it this way? And do do I do it this way, to where they're getting a deeper understanding. So I agree, it doesn't really tell me how to teach that, it just says, make sure that you know that they can do it in these various ways, and it brings it back to my, as a teacher, it brings it back to, oh yeah, I could do it that way too, when I wouldn't necessarily have thought to do it that way.
Because I think most of the time racial and proportional reasoning is more done with numbers and not really done with the various formats. And I think that's why they struggle when they come to high school with so many of those concepts, because we really haven't gone into the depth that we need to.
Yeah, I
And
guess
so-
my, oh, go ahead.
Sorry, seventh grade, once again, I want to say, this is where I really like us to infuse fractions in those.
Make sure that it's really incorporated in there.
Yes, so,
Yeah, absolutely. Decimals as
because
well.
we already talked about doing the ratios and proportions in sixth grade, unit grade,
Start.
those things. But seventh grade, they're doing it again, it's another year, but they're getting the fractions so that when we get them ready to go on to, algebra, or pre-algebra, or eighth grade math, whatever you wanna call it, they've got that solid background and using that.
And I guess my point I was trying to make is I think what's in the Massachusetts needs the amplification of this, and I think it needs, we did professional development this summer with teachers all over the state on nothing but racial proportion, and it's amazing how many things that you can talk about there and that are really important kinds of things.
And what we did was not just Common Core.
No,
We just did
racial
Racial proportional.
meaningful mathematics.
Right.
And I would like to get too, and I do want, I think it's, we can't be reminded about not being too prescriptive too often at all, but, I think that there is some validity to the idea of including some of this, because I know that, when I have had conversations, as to ratios and proportion, what does that mean? Well, to me, coming from a college environment and then going into high school, it's, can you identify the constant of proportionality? To me, that is part of that. And so I get it. I think those things are good and helpful things. I do think there's a little more, there's helpful and then there's, going a little beyond that. I think we do want to be careful with that, but I do think that, some of those things in there can be okay. So I don't doubt the experiences that you are describing, and that would be consistent with what I've seen too.
So I am putting down as a reminder, lean more towards common core document for ratios and proportions, but avoid prescriptive.
Right, anything that's prescriptive, I agree.
Can we,
Yeah,
not prescriptive, but real world, so students are getting a grasp on.
absolutely.
I'm more and more the things I'm doing with these students at the first that are thinking about, they don't understand the rates
No,
at all.
no,
They can't use it, it doesn't mean anything. And we're talking earlier about these people when they're old and this, they'll take care of us. I work with a lot of health
Yeah.
students, including adult health students.
yeah,
And they're trying to do medicines and there's rates and several different forms,
Oh, great,
and they don't grasp.
I'm gonna be
anything about
lobotomized.
Fortunately, my niece is an RN, so I'm just gonna let her take care of it. But yeah, I agree, we
Not
need to,
prescriptive, but
I think we
real
need
Contextual,
see them
yes.
contextual.
Yeah. that, and I think that's something that, when I read the Massachusetts document, and maybe it's implied, but I was really looking for a lot more things in context.
Yeah.
That we want, because when you put things in context for kids, it becomes more realistic, and a lot of times they can solve the problem better if it's in a context than if it's just isolated facts. So, however we put things together, it's really important that it's in context, because I may be able to multiply them in multiplication facts, but if I can't use them in a context,
It's more than just applying, because when you
Yeah.
look at things in a context, you see things you don't see normally.
yeah,
Context actually helps you understand the mathematics.
yeah,
And
that's,
so I think, and that's a lot of what we were doing this summer, we did a lot of contextual kind of data things with
and that
ratio and proportion, and you start to see things that you didn't see before,
right, I
about
agree.
ratio and proportion.
And it was for me as well, when I started really looking at things that help me, when I see things in context, it really helps me understand things better. So I think we need to do a better job overall with putting things in some kind of context situation. So that could be just a segment that we just need to make sure that we include that as often as where it's appropriate.
Well, I think the mathematical practices of the current standards help bring that to the forefront too, and then have first part of every grade level, so hey, don't forget, you gotta be doing these things within
matter
this
what.
content.
So maybe one of the examples or the clarifications could be something like you've seen in the health profession or
Right.
this. I mean, so it has that real world example, because as I work with teachers, they went to school,
Mhm.
they continued school, and they're back in school.
Right.
I mean, they were never out in any other career or profession
Right.
That's true.
to know the application.
So
But
you-
it's not, I mean, they'd love to have it.
And so to help, the more we can help teachers with contextual situations or where they can use it, help them understand that it will only help their kids as well. So the more we have that, that's so good that you're on this to help us.
I just wrote an article about that.
Good, good for you. Good for you. Is this the first place you want on, the statement, is this the first place absolute value comes in?
It shouldn't be, that's what I said should belong in sixth grade. If you're gonna talk to kids about what a positive and a negative number is, and probably distances between points that have the same X value or the same Y value in sixth grade.
Yeah.
But we talked about that, just,
And I think that was actually in this document, in sixth grade, the horizontal distance between 2 points on a horizontal line,
Or
distance between 2 points on a
Yeah.
vertical line.
in sixth grade, then you
Yeah.
need to discuss absolute value.
Yeah.
Because that was
That's-
missing.
That was back in the sixth grade document, but they didn't talk about the
Yeah.
absolute value there, and I think that
That's
was
why I
should.
said that we should add it here.
Yeah.
This is
Yeah.
one that, to me, the EG really bothers me. Demonstrating understanding of absolute value. Absolute value -3 equals absolute value 3 equals 3. That's it. That's all I need to know.
Yeah.
I mean, I know that's not what they mean, but that's kind of what it sounds like, isn't it?
And as a teacher implementing that, okay, they just need to know that
That's,
they have.
you need to know more than that.
Yeah, if you give them that example, that's all they need.
Yep.
That's what I feel about 8 and 2, that I felt about it when it was in the Common Core document, specifically mentioning square root of 2 and pi.
And those-
Yeah.
Those are the two.
Yeah.
Okay, got those done.
I agree.
What's going on?
Mark it off.
Seriously, not that the other wasn't, but, the first one, we see more of seventh grade, we said, and eighth grade both, 8 and 1. Those comparing and ordering and all of those things.
Yeah.
8 and 2, I see it irrational more as eighth grade.
Or your accelerate, if you have an accelerated
So,
path, I think accelerated 7 could do it. But your general,
When I'm talking about just general
Yeah,
standards, I mean for
I think we're
all
talking
the
about
children.
driving accelerated, yeah, but this would be a standard that we do. But I think that by the end of seventh grade, we want them to have a really good command of rational numbers. Really good command. If they have a really good command of rational numbers, then we can introduce the topic of irrational numbers. Their eighth grade year, but I really get, they have to have a good command of rational before they move on to irrational.
And then 3, that's the one where I put that we lean more towards the Common Core ordering of it, avoiding prescriptive, real world contextual, so Dave doesn't take too much medicine.
Or not enough.
I don't know.
There you go.
Just to make sure I'm taking his notes.
And I know 8 and 4 talks about representing numbers in scientific notation, but I didn't notice any place, and it could be going back and look in the seventh grade document, that they translate back in between scientific notation and standard notation or standard form. Is it in the seventh grade? I didn't notice.
There's a 6 and 3 represent compare very large and very small in various forms, such as expanded notation. So
It's kind of the,
that's not the same thing,
Yeah.
but it's perhaps getting you ready for it.
right.
So,
Now, Massachusetts puts that as 7th grade, don't they, Maggie?
yeah,
That's
they do
just
7 and
percent.
3 represent numbers in scientific notation, positive powers of 10 only.
I
use that notation properly.
Myself.
I agree.
So that
Did you
they,
say it said positive powers of 10 only?
In seventh grade. Yes, positive powers of 10 only in scientific notation.
for scientific notation, but it doesn't talk about translating back and forth in seventh
It's
grade.
an eighth grade common core, right?
Yes,
it is.
Yeah.
Yeah, 84. Because it's connected to. Take that back.
So are we okay with that being in eighth grade?
Yeah, and
So 7 and 3 and 8th grade.
The in 3 is in seventh grade,
Move it.
I'm sorry,
I know.
excuse me, 7 and 3, you said, right?
Yeah.
Yeah, to eighth grade is, I'm open to the large numbers or the positive exponents being in seventh grade and then moving into it with negative exponents or
In eighth
small
grade.
numbers in eighth grade. I mean, I think it's worth us thinking about, but
yeah,
I would think about the whole thing, kind of getting it down pat as eighth grade.
by the end of 8th grade, they would be able to fluently, or we would use that
Go
word.
back and forth. I mean, I'm open to both, but I just think that if you're gonna get into that, that's just another thing that you have to go off and do, and it won't seem so connected if you,
Yeah, I would think that they need to both be in the same.
And here is one thing, I guess, a little fine point I'm gonna bring up, is that where is this needed in science? Because scientific notation,
I know, I was thinking
Well,
about
Yeah.
the next generation science standards introduce it either at the same grade level or after the Common Core.
so maybe we can put that in our notes, that this is, we think it can be here or here, but we really need to know. Well, because what I've found has happened is when we don't teach the mathematics, and then science uses the mathematics, and when they haven't been taught it, they just have them memorize things, rather than helping the kids understand it. Case in point was when distance equals rate times time formula. I asked the science teachers, because they were having them do that before, we had taught them how to solve. And that's, I said, so how do you teach them? I said, how do you teach them to solve? And they said, we don't, we just have to memorize the various forms. And that's not what we wanna have happen. We wanna make sure that we're working, so we need to look at some things like this, definitely with science. Maggie?
The scientific notation, case in point with science and math and not jiving, my daughter took an online from Mobile, and the science teacher was using a 6th grade level scientific notation, got it completely wrong. And one of the students actually questioned her about it, and she says, oh, we use a different method of scientific notation for science.
Hello.
And yes,
They use a different notation?
well,
Scientific.
she was moving the exponents the wrong way when she was performing the operations, and I got on.
Bob,
And
I
I
come in and pull
I
that
called.
stuff to your students.
Yeah,
I don't think so.
but when you say science and math, you need to get on track,
Yeah.
and so that they're taught it
Even,
from a mathematical
even solving
perspective.
literal equations and things like that, we need to make sure
Yeah.
cause we just need to make sure we're doing this.
I'm not sure this
It was
is where it will end up. I
Sure.
just Googled next generation science, scientific notation. I don't know what they're doing, don't know what
Yeah, no
they're doing
idea.
there, but it says 8th grade. Yeah.
So, because regardless, we need to make sure, I want us to teach it.
Yep.
Personally, so that we can make sure that the kids understand the process and not just be handed to them, so.
So then the trick is to put it in 7th grade, so that they can't mess it up.
Beat it to the punch.
Beat them to the punch, there you go, Because even when you go with that, if math teaches it at the end of the year and science uses it at the beginning of the year, then there's also that one,
Yeah.
so. So I just wanna make sure we think about things
Of
like
course,
that.
really, I mean, scientific notation is a form, it's really experts.
Yeah, I think it's good for kids to do all that. I mean, I'm just looking at it as a physics teacher. I don't know that you really need scientific notation until you're ready to start talking about sig figs, and you don't do that until at least, your second chemistry course or your physics course, not the one you take as a 9th grader. Like, that's my personal view anyway, that when you get into that, scientific notation really becomes something that you'd like to have. But I also think it can be really good, and I know that of answers. You know, do you expect your answer to be big or little, and think about the character of the exponent and things like that. So I think there's a lot of opportunities for math teachers in that topic.
Right. Yeah, but we just need to make sure that we're somebody working with science to make sure we're doing the appropriate grades.
I think if we keep in, like in Missouri's standards right now, AEE 3 on page 54.
And does anyone else need a copy of the Common Core?
Page 54, you think?
Yeah.
Okay.
My seventh graders would really struggle with stuff like that. That's very abstract for them.
Say it again, please.
My, on page 54, AEE 3. I think that's too abstract for seventh grade. So if we do move scientific notation to seventh grade, I would think that this part of it would need to stay in eighth.
I think all of it needs to be eight.
I agree. I'm just, if we do move it, we really need to think about that one.
I agree.
This is the part where we will be doing operations with those, with that form, and it's just one of the few number sense things that we are doing. There isn't a lot of the number system here. There's some irrational numbers are placed here and things, but I think this is one that we do need. By the way, Anne, you weren't in the room when it occurred to me when they all corrected me. I thought you said that you didn't like number sense. And I said, no, she said number sentence.
Every time she'd say number six, she'd point over here and say,
I kept sitting there thinking, why does she not like number sense? You weren't in the room.
He's on the wrong group.
Ding dong.
You're getting poetry group.
Okay, so we're down to 5 at least, right? 8 and 5. And 8 and 5, we've already talked a little bit about factoring. They're talking though about prime factorization, which I think goes along with doing the multiples in the
6th grade.
Yeah. Now the relatively prime, I don't have a problem with that being back where we was either.
Yeah, I mean, when they're doing GCF,
Yeah.
I can do that,
Yeah.
yeah.
So I'm gonna put
needs to go there to me.
I'm gonna put 6th grade on this one, okay? Okay, and then we did already talk about 8 and 6 because we had put that in 6th grade as well.
Right.
Since we're having
And then the distance on another one.
yeah, if you don't talk about that.
Strike the E.
Yeah. And strike the EG, yes. Yeah.
Okay.
You know, is anybody thinking about that? So roots, that just means square roots. Is that what we think there? We're gonna leave all the other kinds of roots to.
I think that, yeah,
Yeah, I think so.
I mean, square roots,
So
yeah.
they say
Square
square roots in the
roots.
second place, but not in the first part, sorry.
They do talk about some, I mean, and I think it fits nicely, cube roots, only because when you start talking about volume.
Yeah.
And you start talking about what would the side of a cube be
Yeah.
if the volume is this,
Right.
then knowing how to find that cube root is really nice. But it's nice, I'll call them friendly numbers, no, I'm not
Yes.
gonna write friendly in the standard. You know what I mean, you know?
Yes.
Well, you could say for perfect cubes, things like that.
Yeah,
Yeah.
the common course is squares and cubes, so.
And I think cube roots makes perfect sense when we're talking about volume, you know, so area, volume, I think squares and cubes, I think beyond that is not appropriate at this grade level.
And Julie's right, in the current standards, it says small perfect squares and cube root of small perfect cubes.
Yeah.
So I'm just out to the side putting cube roots.
Yeah.
I mean, we'll rewrite later, but
Sure.
that's okay with everyone?
Oh, yeah.
Yeah, and I just think if we specify that, you know, it's just so
Right.
that, and then teachers know exactly what their expectations are, and test writers know exactly what the allowed choices are for them.
I even think if you put cube root, perfect cube root less than,
Certain number, yeah.
because
We
we
can
don't
get more
want to.
specific later.
Yeah.
Because we're not gonna have something that's outrageous in size. It's, You will.
Nor do we want to accept the outrageous since I was on the assessment.
Yeah.
Just saying.
And once again, I don't want to get too prescriptive. On the other hand, the idea is for a kid to realize that a number times itself is something, not
Yes.
to
Yeah,
memorize,
right.
13 cubed or 24 cubed or whatever. Okay.
It says use associative, commutative, and distributive properties. Would they have to define those properties or just be able to use them?
I would want them to just use them.
That's what.
I don't care if they know what property it is in that grade. If you want to do a formal proof later on and they have to identify it, okay, but I just want them to be able to utilize them appropriately.
And I would like teachers to be able to tell them what they're doing with this, but I don't think kids even have to define, like we're gonna use the associative property, we're gonna use the community property, but not in an assessment. That type of thing. I want them to begin that language, but I don't want that to be assessed, because if you don't begin the language until a lot later, it's really hard to deal with. So I want them to begin the language. I don't care if they define it at that point, but for the teachers to use the language.
I agree very much with that. I mean, so does this happen to other people? Do you tell somebody to multiply and they don't mean distribute? Does that happen?
Yeah.
That happens.
I do.
Provide the
so-
papers to the class.
Yeah, there you go.
So,
I timed it.
I timed it.
Yeah.
Did you plus it?
Yeah, I plus that. I had them say that.
So is use a strong enough word so that we don't end up, because I was looking through something the other day and it wasn't Common Core or anything, it was a computerized thing, but yeah, there was problem after problem after problem. And, the question to be like, which one of these shows the associative property? And all four of them were equivalent to what they started with, but you had to pick up one that's so does use or apply, or can we somehow get that verb in there so they don't have 20 questions on which one of these is communicating?
yes, please, I would like to see the end
Yeah, I
of
don't know what
that
that magic word is, but
Right.
somehow so they don't have to
Yeah, I
identify it.
totally
I'm like
agree.
you, if they can use it, that's what I want.
Yes.
Right, and
Define an equivalent
same thing in our
expression.
closure.
Yeah, right,
Yes,
it's not,
yes.
it's not,
So what
which one,
you're-
and they're all.
What
four
you're talking about is
It's
equivalent
frustrating.
expressions. I want them to
So
know
maybe
all
it
of
is
them.
to use them to find equivalent expressions.
Right, use them, yeah, that
It's
might
not
be, use them to find
apply.
equivalent, use the associative community to find equivalent expressions.
Yeah.
I don't, Julie, were you gonna talk about closure? I don't know if I like that part of this.
Well, I don't necessarily, I mean, so that the idea of closure, just say, so, are you always gonna get, a whole number if you times two whole numbers together?
Well,
But, if you divide, do you, I don't think that's a bad notion, I don't think that's a bad conversation, I don't know that it's necessary. So I'm okay with that, but do we want to teach them to call it the closure property? I think that can go the way of the first grade.
I don't think it fits here, because
No.
to me, we're talking about using these to simplify or to write an
Right,
equivalent
equivalent
expression. You don't use closure to write an
Yeah.
equivalent expression.
and
They just do it in here because it's a property.
right, I think it's the
It
concept
doesn't
of
fit.
closure is an important thing to realize.
Yeah, but I don't think it
Then
fits
you would
here.
multiply two even numbers together, you always get an even number. When you add two whole numbers together, you always get a whole number. That concept is important, but like I said, I'm not sure why that got thrown in there.
It's a property.
Yeah.
Does that need to be a standard in middle school, or are those just good conversations to have with students?
That's a good conversation.
Yeah, I don't think it's a standard.
I don't either.
I don't think closure needs to be in any standard in middle school, but
No, I think, like you said, that's a good conversation. Those discussions to have that when we, kind of like when we multiply two integers together, we always get an integer. That we multiply two rational numbers, we add a rational number plus a rational, we get a rational. Those kinds of discussions are important, knowing the name of closure.
But I tended to do them in algebra 1,
Yeah,
not in middle. I mean, we may have talked about it, but
right.
a lot deeper.
Because you can,
I have conversations, just on a daily basis with different things, but have I ever talked to my kids about closures?
No, I never thought of it.
And my kids would have looked at me outside if I didn't.
yeah, exactly. I agree.
It's not a hard idea, I know teachers who didn't know what it was, other teachers who try to give like super complicated explanations and then I just, well, it just makes it, you get the same thing that you started with.
Yeah.
Yeah.
Same,
So,
doing the same phone numbers.
Yeah, so, I mean, I tend to think it's not important, but maybe that's, the idea of it can be, but
Right.
I think this makes it too big of a deal.
And at this level.
I agree.
Yeah.
I agree.
Doesn't need to be a standard.
Yeah, I agree wholeheartedly. Use that word simplifying.
Well, I certainly like the phrase equivalent expression, so if we are, you know, going around cleaning that one up, we think that we will have our privilege of being inherent.
And that's current, in our current standards, equivalent expression shows up in law.
It's about being flexible.
Yeah.
I mean, it's about being able to change something to make it look the way you need it to work with it.
For what, for the purpose you need to use it for.
Well, then even worse from fractions to decimals to percents,
Yeah,
finding
that's-
equivalents
Right.
instead of.
Right, and to realize that 1/2 and 50% are the same
Right.
thing, right?
And simplifying reducing fractions.
Yeah.
No, they're equivalent.
Yeah, they're equivalent.
Other than the squaring and the square roots, I really think most of this is almost sixth grade. Addition, subtraction, multiplication, division, that's how you're gonna solve those equations. The square and the square root, I think, is elevated to eighth grade,
I agree.
and I think the rest of it is sixth grade.
I wouldn't, yeah, I think you're probably right.
Except did we put negative numbers in here?
They're not adding and subtracting negative numbers in sixth grade, I think they're in seventh grade, correct? But
Yes, but
Yeah.
just the basic, that's a good point, Andy.
yeah,
Addition, subtraction, multiplication, division, maybe we could say, non-negative numbers is sixth grade.
Yeah,
Yes.
Negative numbers can be seventh grade, and
and
then square roots can be eighth grade.
right.
Yeah.
So
Does that sound like natural progression?
if we're gonna go square roots, because we talked about cube
Cubes.
roots, yeah,
Yeah.
should we do square roots and cube roots, since that's what the topic of discussion has been?
Yeah.
To keep it consistent with that grade level.
As long as we don't do fourth roots, I'm
Oh,
totally.
come on.
Square roots and cube roots, and do we need them to recognize, an exponential notation like x to the 1/2?
Would that be at this grade level, or would that
Would you
be
say,
at fractional?
fractional exponents?
Rational exponents.
Rational exponents, we do that in high school. Currently.
Because I think
I think it's, I think it's
Um,
an
it's in eighth grade,
It is in eighth grade,
EE1.
yes, it is in eighth
It's in
grade,
eighth grade in Common Core.
It is.
not with negative ones, just
No,
with
just
positive,
positive, to
rational.
recognize it
I
as,
think it's positive rational.
it is, I think,
Yes.
I think you're right.
So in the real world,
Mhm.
how do you see them then?
What do you mean?
What
You
you're
say
talking
that
about,
In
that
application.
In applications,
I
like
think our
square
depends
roots,
on
do you
which.
see the square root of 9, or you see 9 to the 1/2?
But the advantage of, when you talk about square roots, talking about fractional exponents, is they can answer questions for each other.
They do.
Kind of help it explain
Yeah,
things.
The reason I like it, the reason I like it in eighth grade, Margaret, of all the subjects I ever taught, and I didn't teach calc or pre-calc, but of all the other subjects, the most jam-packed abstract thing for kids was algebra 1. Algebra 1 had so much stuff in it.
Oh, so you're saying do it in eighth grade
So-
before they get to algebra?
That's one little thing that you can do there, and I don't
Equivalent way
think
to
that it's a.
It's an equivalent way to write it.
And when you're talking about exponents and square roots, it makes sense to talk about it to me.
And not necessarily, I mean, x that are like the square root of 2 another way, or the square root of 3 with another way to write it would be 3 to the 1/2 power, and cube roots, but do we want to extend beyond that, or we just want to do that square roots and cube roots and then maybe extend it later?
I just think square and cube, are you talking about for?
To write it in exponential, to write it as, and the square root of 3 is 3 to the 1/2, and cube roots 2 to the 1/3. Do we want to just leave it as square roots and cube roots, or do we think, because we've been talking about going in depth, do we go further in depth to that, or do we stop it there?
And are you talking about just teaching them that notation, or are you talking about helping them understand how that creates latter, I think it's gonna be pretty fun.
I think that you can develop it, I just don't wanna see fractional exponents, you know, I don't wanna see 2/3. But
No.
I don't even mind if they're integer exponents. You
Yeah,
know,
to the negative, yeah, to the negative one.
So you're just really talking about teaching them an alternative notation. I guess that would be okay.
equivalent expressions and
Yeah,
talking,
right.
and why it means that, because you can show that. I just, you know, I don't wanna see,
Where is that in Common Core?
where's what?
The rational exponents? I'm
It's
still
on
looking for it. Yeah, I'm looking for that, but I'm not sure it's what AE two
No,
is
it's
saying.
the number and
It's
quantity
the rate in
in
the
the high
fractional
school.
base, yeah, it's not,
and real number system, very first thing in the high school part.
so it's not an
It's
eighth
very
grade.
first thing.
It depends on what we're talking about. I said rational exponents.
Yeah, I don't see that here.
I'm sorry. I don't wanna use rational exponents. I will use positive and negative, I will use integer exponents.
Oh.
And do operations.
On rational
Maybe I
numbers.
misspoke.
Okay,
Yeah.
that's why, I thought you were saying rational exponents.
I know, I didn't mean to, I apologize.
I'm
No,
okay.
I don't wanna use rational
Okay.
exponents, but I do think that we can. Oh, get over it.
Delete.
So, no, you don't have to do it, you can just say, Nancy. I want to use positive and negative exponents.
Gotcha,
Sorry about that.
But not fractional, not rational.
I misunderstood that.
Because that's what she said.
There's all the technical candy.
So, wait, where did we leave that? In 7 or 8?
So we said 8 was integer exponents, right?
Mhm.
That's where you're doing the integer exponents. is it?
Right.
Okay.
And then moving on to high school, I think
Then
would
you
be
get
where the area would do the rational exponents in algebra 1. Yeah, that's fine.
So. Okay, I see, it's the same as 8 and 10.
Mhm. And then 8 and 10, then use that simplified one.
8 and 10, it's not important estimate, is it?
Maybe not so much in the medical field.
Yeah, a little precise.
Yeah, just a little bit.
Banking, now you can answer me all you want.
I think we know what we mean when we say estimate.
Mhm.
I think some
Yeah.
teachers see it and they think round.
Yes.
And students, you can
Yes,
preach
okay.
that to students the correct way for all year, and they're still gonna not know the difference.
I think it's more about reasonableness,
Mhm.
and, I mean, estimating is more than just rounding. So,
Yeah.
I mean, I don't know if we need to say more, but
But it goes back to context again.
yes.
Yeah, it does.
It's kind of like 8 and 11, it does say determine when an estimate rather than an exact answer is appropriate and apply in problem situations, and I think that it means like application problems, like Julie had mentioned earlier.
Sometimes rounding does not give you the right answer.
No,
That's correct.
Like, if
The
you
bus.
figure out you need
Bus.
2.4 buses,
yeah,
you don't round to 2,
no.
which is the way you would round it.
Yeah.
So,
Well, sometimes, yeah, and what I would have said is, sometimes it's appropriate to round it up no matter what,
that's right.
and
And I think that goes back to what I really like, and I can't remember what grade level it is, I think maybe 5th grade or 6th grade, in the Common Core document, they talk about interpreting the remainder.
Yeah.
You know, and that's what it really all is about, is when you divide what that remainder is and how it's gonna be used, because you can get an answer and be used 3 different ways depending upon the context that the problem's in.
and so, I have to tell this story.
Or tell
So-
stories.
And this one's not even funny, and so, when I was serving on this teacher ambassador program for SAC, I sat down and went through, as part of this program, so we went through some of the 6th grade problems that they had. And there's a problem that, and so I went through and I tried to find higher DOK ones, and I thought, I'm gonna go through these. And so they have this complicated problem about a person putting apple slices, putting peanut butter and raisins on them, and it said and this person will keep doing this until she runs out of peanut butter, till the peanut butter is all gone at the float. The problem then, so you take the fractional quantity of peanut butter she has and divide it by, the number of, or the amount, the fractional quantity that she puts on each apple slice, and you come up with a fractional part. And it was something 0.4. And so the answer that the SAC people had as correct would be round down, calculate the answer, and so I, jaw drop, hey, wait, this is a problem. This is a perfect example of where you would obviously have to round up. And their response after a long period of time was, maybe after the field test, we'll decide that your answer is okay. And so I'm looking at this and thinking, wow, you guys don't know what you're doing. Because this is not a complicated situation. You don't need a genius to straighten you out on this. Either the peanut butter's gone, or they, and a kid is going to see that. And so, great problem, wrong solution, they're not backing down. That should give us all pause.
And but I will tell you, because I was involved in Rotary doing some assessments, that also has happened on the performance tests in the state of Missouri as well.
Oh, I don't doubt it.
And so it's not just there, and it's also happened on IB tests that I've been involved with as well. So it's going to happen everywhere, but I agree that we just need to really be cautious about no matter where we go.
Which is great. But I just think that's a great example too of a problem where, you would round up with purchasing decisions. Kathy's part of the bus problem is one of those too.
I think I'm just looking at the task, like see peanut butter raises and
Yep.
apple slices.
Yep.
Yeah, because I'm saying, I just saw that.
You're a true math nerd if you.
And they had,
Yeah,
they
she
said,
is.
and they said, they changed the problem.
She looks a lot of stuff.
So the problem is what fractional part of the raisins did she use?
No, that was always the answer. But you only get that answer if you round down.
Oh, okay, I haven't worked probably, but I've never seen it.
Yeah.
I'm gonna go work it out next night.
I didn't write
Is
anything.
it easier to change the test questions if they're a state test than a national?
No.
No.
Well, depends on how the state gets them, because
Yeah.
oftentimes the state sells that out to somebody to do it. Usually they do.
Well, in this case, it's CTV for both of them.
Yeah.
Smart balance and
Same
state
kind.
test.
Yeah.
Yeah.
Well, and part of that goes back, we do things in our classroom all the time, that I want to, but if it's a high stakes test, we want to make sure that it's right. And we've had that happen, I know through several rounds on the other test, on the math test, that it comes back and say, when we're talking about discrete data versus continuous data, that, there have always been some issues, and so part of it has to go back to,
It's just, it's the scope of the people you have to deal with. We had a math
it's
contest
huge.
Saturday and had a bunch of high school kids, and we found a mistake on that test. Well, there's 10 of us, we fixed it. But you're not dealing with 10 people in a room
Right.
together, so it's
we
harder to
have
fix.
thousands, and it's very difficult to get to someone. You try your best, I think in all fairness, there's going to be some, it doesn't matter, there's always going to be something that gets through. You just have to do the best job that you possibly can to monitor that, and hopefully that will change for the future, so.
Except I brought it to their attention.
Yeah.
Or your police to do
That's the math.
That's where.
The same thing happened on that test.
I always wait to make the keys on the test until I grade the best student on my class's test. Because I always make mistakes on my keys, so it's just what happens.
But you're right, because I've had that same impact when I've worked with that, and it's kind of like, how do we solve, yes, it is, it's very frustrating. Okay, so are we down to like looking at, and when we were talking about 8 and 10, again, I like that word simplification.
I think you
So,
probably just delete it on that one, because we've dealt with it
Right.
elsewhere, but delete the parenthetical.
yeah, I don't think that's necessary.
And then think that's the 12 again, is a reference to word problems.
Yeah, I think so too. Yeah. And I'm not sure that we need to say select and use appropriate operations, I would just say that they can solve word problems with rational numbers. And that to me is probably appropriate for 8th grade or 7th grade.
Which one's that, Kathy?
8 and 12.
Well, we had mentioned that we wanted them to be, really good with rational numbers by the end of 7th grade. We said good with rational numbers, so.
And this is positive, and this one also includes positive number exponents, so we keep that at 7th grade as well.
I guess, I don't care if we put that in there, but don't you think that's gonna be inherent in our other standards, that they're selecting and using the correct operations? Whether it's at 6th grade with just positive numbers or 7th
Yeah,
grade?
I kind of see that, I'm not really sure why that's there. I'm not saying solve problems.
Yeah, I don't have a problem with it, it's just, we kind of have that in,
I would think.
I agree.
I'm just gonna add it to a little text.
Is the focus on positive integer exponents?
Well, what I'm saying is that no matter what grade you're in, we've talked above about they're going to use positive integer exponents. We've talked about that in other places. And yeah, I wanted to know which operation to use when they use them. And I don't mind if we keep it in, I just think it's.
That seems
sort of
like the
redundant.
focus is that they pick the right operation to solve the problem.
Right.
Correct.
So it's back to the problem. thing.
Right.
So is that a standard we wanna have?
I think it's part of what we've done.
Kind of an observational thing, you
Yeah.
just expect it to always
Right,
be.
they should be able to solve problems.
And they actually listed that same thing for 7th grade.
Yeah.
It was
Yeah.
repeated at 8th.
Yeah. So, anything else in number?
Not in this document.
Do we wanna look at patterns in this document and?
Yeah.
Okay, so let's go to patterns on page, 63, is that right?
You? I don't know what Lisa would say about this, I mean, how she was with her patterns and not being able to tell where they go until you have seen them in certain places. I mean, I think that was part of her major point, honestly, from this pattern and stuff.
Of course, you can, I mean, like number one, there's a lot of stuff. in number one.
There's a lot, that's a lot.
But I mean, you can know how it's generated, and that way you know what's gonna happen, and still notice patterns. You know what I'm saying?
Yeah.
I understand exactly what she's saying, and I agree with that. That, you know, just because you list 3, 4 numbers in a row doesn't mean you necessarily know what the fifth is gonna be. Even if you see a pattern, it could be the wrong pattern. But if you know that it's generated by some mathematical thing or context, either one, then you could say what the pattern is. You know what I'm saying? In other words, looking at tables of linear functions, knowing it's a linear function, you should be able to see the pattern of what's happening. Don't act like that.
I always think when we talk about that, I always think about that pattern 1, 1, 1, 2, 1, 1, 2, 1, 1.
I mean, I think there's value in AP1, and there's just a lot of stuff there.
It's a lot.
A lot of stuff. Seems, and
Unless
some
you
of
can-
it I think we've probably talked about before,
I think it has.
when we talked about linear functions.
Yeah, right, I like the content of it, I don't know that I'm sold on something called patterns, relations, and algebra yet.
Me neither.
Yeah, I'll have to talk about
Yeah,
where it fits
Don't
in,
make
but
it
as far as the content of what's there, sure, I guess, arithmetic and geometric progressions. I'll think about. What do you think, Deb?
Well, it's,
I think implementing that standard in and of itself right there is a nightmare. Just
All
because
year
it,
long.
Oh.
We can't work on it all year.
yeah, I mean, as a teacher, I would be like, why would have to go through each one of those to make sure that it was covered. And so just to make sure that you implemented that one standard the way that it's worded.
But arithmetic is linear, so
Right.
you know, that's okay, I think. Have we talked about exponential functions yet?
Yeah, we have much.
So that doesn't make sense to
And you
me,
won't,
unless this is where we wanna start, but I don't think so.
I don't think we do, that's why I said
No.
arithmetic
Please
and
don't.
geometry.
No, I don't think so. So I think this could be rewritten as, looking for patterns related to linear functions or something like that, but I mean,
Well, I'm starting by scratching up geometric.
yes,
And,
I agree.
e.g., I'm scratching that out.
Yeah. compound.
Compounding, good move.
Okay, and then we'll just rewrite, I mean, I think all of these things are important.
I do too.
I just don't know that they'll be right here.
Julie, you start to say something.
No, well, I think that BP one is just a nod to what these days is, I think still called the rule of four, where you just look at, you know, each type of thing with respect to, you know, tables, graphs, you know, symbols, for lack of a better word, and then verbally. And so, I mean, you could take out that whole AP one, you could just delete it right then and there, and I think, and you're still covering those things, because for example, number 4, AP4, says create new symbolic expressions and relate them to verbal, tabular, and graphical. So you've done it again, I think,
Yeah.
unless there's something else that
Yeah,
I'm not seeing.
And I think, well, the only thing you'd be looking at here would be linear kind of.
Right.
Arithmetic kind of sequences, and so, to me, when we're back in, you know, other grades talking about linear, you have to show tables and graphs, and
Right.
so I don't understand, it seems redundant.
And well,
Yeah.
AP4, what it doesn't include, I think, is the symbolic expression. Oh, no, it does. Create new
That's-
expression.
Yeah.
You're right.
Does it seem redundant at the end, Bob?
Yes. It's like deja vu all over again.
And so the only reason you would ever, you know, wanna look at geometric, you know, is just because if you're gonna look at linear, then you should have some kind of conversation about what isn't linear.
Monotony.
So, I mean, it wouldn't have to be geometric.
So you could just say non-linear.
Right.
Yeah.
It'd be linear and-
Yeah, I'd be okay with that.
Well, I'm okay with saying that we look in a separate standard, say something about look at linear or identify which are linear. But I don't want them extending, representing, analyzing, or
And
analyzing.
Yeah,
things.
no.
Is that okay?
Yes, I mean, I agree with that, I just meant to say the only reason, yeah, I don't want them to do that either, because I think there's a lot there, and it isn't necessary, it'll just cause a lot of confusion, and it doesn't need to, because they can do it later and it'll be easy, and, so, that was my only point, was that you would wanna have something to sort of compare it to.
So maybe identify linear, would that be okay? So
Linear.
we're not linear, not linear? Because if we keep this the way it is, I think Tiffany's gonna get out of, so.
No,
I need to choose something different.
Well, we should always be thinking about that first-year teacher in a small rural district who doesn't have a whole lot of support and, you know, and the historical background of the veteran teachers, and say, what are they gonna make out of this?
Yeah. So I'm just kind of putting redundant off to the side, I scratched off the end after arithmetic, and then over here I made a note that somehow we want them to identify linear as compared to non-linear. So,
Yeah,
And that could be
and I-
from tables and graphs.
Yeah, I mean, I think if you look at Common Core, I know we're not quite going back and forth yet, but I mean, 8F, which is functions, they also do this with linear functions themselves. Compare properties of two functions, each represented in a different way, algebraically, graphically, numerically in tables, or by verbal descriptions. And you're looking at when they have different rates of change, if they have different initial values. I mean, it doesn't have to be just linear and nonlinear, it could be linear and linear as well. So I think it's using the multiple representations to compare linear functions to each other and other things.
And I think that middle school kids are ready for that developmentally, and the majority of your kids can understand all of that. When you go to write rules for something that's non-linear, is when you're
Yeah.
over their heads.
Right.
I mean, like, your accelerated kids can get it, but the majority of your kids.
Yeah.
Unless you're doing something like doubling.
well,
Right,
or
something simple.
squaring.
Yes, you're doubling, squaring, those
Good
things.
task.
Define real basic things.
Right, really simple things.
And Bob, I think the one that you're talking about comparing linear, it is HP10 in Massachusetts.
Okay.
take a look at that and see if that's sort of what you were talking about.
Yes. Their growth patterns.
And it can be the things that are non-linear, you know, the simple stuff, doubling, squaring, you can also do just an oscillator.
Mhm.
1, 0, 1,
Yeah.
0, yeah, so, easy stuff. But there's,
So are we coming down to the side of that P1 is unnecessary?
I guess,
Yeah, I think it's unnecessary. Well, I mean,
or can be incorporated within others.
That's what I think it
That's what I'm saying, it's already
shows up
covered
in
by-
other areas.
if we want to have one that says comparing linear to nonlinear, that's not here, right?
I think that what I wrote down was that maybe we need to have one that says identify linear,
Okay.
which means you necessarily have to know if it was nonlinear. And that could be in different representations, I think, so.
I think that's really important,
Yeah,
really, really important. That's back to the modeling thing.
So
Being able to identify
that's
what's
what I
there.
wrote down, I'm not, I think that once, I'm assuming that I get to be on the middle school group, because that's what I really know, that I think that that's when that will start being crafted into real standards.
well, they're kind of saying the same things over and over.
Yeah.
You have, 87, set up and solve, that may be a little bit different, but then the other one just said analyze and generalize. I don't know what that means, but set up and solve is maybe more specific, but you're still doing the same thing. Although I would remove with 1 or 2 variables as being redundant, for sure. And
On AP2, we had talked earlier about introducing variables or unknowns in 6th grade.
6, I think that's 6.
Yeah, we had talked about that, and then to me, and maybe not the exponents, if we haven't introduced exponents yet, but don't they come as positive exponents or anything?
Positive exponents, I think they are.
Yeah, right. No, positive exponents, I think we said 6.
So,
And identify or kind of evaluating an expression or saying when 2 expressions are equal, those kinds of things are 6th grade things.
so I would think that AP2 is a 6th grade kind
That's
of
what
thing.
And the expectation is when you get to 7th and 8th grade, you've done negative exponents, that you still should be able to continue to do that same kind of idea, because they understand this concept, they understand negative exponents.
And you can work in your negative, your integer things there as well,
Right.
but, yeah.
Oh, we're really digging down to that, fewer and,
Absolutely, that's what we are doing. It's fewer and fewer, because some of these are just redundant,
Okay, AP3. It's pretty specific here.
Yeah, it is.
I mean, I don't know if the rest think that, but I think that's,
Too specific.
Why did they pick that one?
I'm sorry?
Why did they pick that one?
Good question. I'm not sure.
Instead of saying,
I wondered that too. I mean, we obviously need them to know that when you multiply 2 negative numbers,
You
the
get
answer is positive, but I don't know if writing it that way really helps.
I mean, I think it's just kind of absurd. I mean, that should be something, I think kids have it, I think where the problem usually lies is students don't understand that it's the opposite of X no matter what X is. And I think therein lies the biggest issue, that if X is a positive number, the opposite of X is negative. If X is a negative number, the opposite of X is positive. I think that's where the biggest issue really lies, not this. So I think that's helping them understand that when we write that.
I thought that what they were trying to say in this one was really in the second sentence.
Yeah.
So that if you're multiplying the polynomial by a negative number, you know that you can really just multiply the opposite of the polynomial, call it opposite, by the positive number. I mean, I think that that's what they were trying to get across, or distribute the negative, is what you hear most teachers say.
And
I think that's the point they were trying to get across, but still, I think it's pretty prescriptive, I'm not sure.
Why does it need to be? It should be a standard, that should be within, when they were talking about the distributive property, that should just be automatic, that our kids should.
Must
see
have
those
been-
things.
must have been a big problem in Massachusetts.
It
No, I mean, yeah, it is not.
is it okay if I X?
Yes.
you were talking about And they're really substituting with only those positive integers in sixth grade, and they really get that down. And by the time we have negative integers, and they're so used to substituting within parentheses and all of that stuff, that will cut down on that issue, because we fight it all the time.
And a big issue that they'll run into here, which is what I don't see addressed is, and I don't think it's worthy of standard, is that -2 squared is not -4.
Oh, yeah.
You know, that's a huge issue with kids that they don't get it, and so, yeah. Yes, and so if that's an address, and I think that's almost a bigger issue than what this is, and I don't think it's worthy of a standard, I just think it's something that we need to really emphasize with our students, but I don't think that's worthy of a standard, or should we prescribe that much teachers? Those are just natural things we should be doing with them.
Yeah, because if we have a whole standard on just -2
Yeah.
squared.
That's really prescriptive.
You did? Yeah.
But I do think it's gonna make a difference when we move it down, when we move some of these things to sixth grade,
Yes.
that they can really get just a basis, and then it'll make it easier, because right now, it seems like in seventh and eighth grade, we're giving them, oh yeah, now there's integers, and now there's other rational numbers that you don't know about, now there's irrational numbers, and now there's all of these properties. It's too much. And so by taking some of this out and putting it in another grade, we can really focus on that more. We've got more time for it.
And do you think that's gonna result in, hopefully, not every single kid, of course, but more
think
kids
so.
knowing it better, because that's what I think
That's
we
what
really
we're
want to
I
accomplish.
think so, yes.
Yeah.
I really understand.
Okay, so we're down to 4Z, which is, probably wrote it again, just kept writing it.
Some of it is
It's a simplification of one.
Yeah.
So why don't we just kind of keep it in there, but we will just, as we incorporate the ideas. I don't
Yes,
wanna
the
completely
ideas.
scratch it, because we agree with the ideas, and
Mhm.
maybe we'll see the nuance as we
Yeah.
really get into it more.
Right.
Right now, I'm not.
Not feeling the love.
On AP5, I like the concept of it, but I like the wording better in the Common Core document. And of course, I'm gonna have to find it. But it's the one where they're talking, you guys know the words I'm talking. It's the one where they're talking about like basically writing stories from graphs, where you look at the graph and describing what's happening.
You talking about ADF5?
Maybe.
Not 4? Oh, yeah.
I think what Jude says is 4 and 5. If you're talking about the story part, is at the end of 5, but
Yeah.
I agree with Dan that it looks on.
It's a little more related to 4.
I think it looks on 4,
I do too.
but I
I
agree.
like both of them.
I like 4 and 5 in the Common Core, and this
Yeah.
one is kind of muddled.
That's what I'm saying, I like 4 and 5 in the Common Core. I really think that sketching a graph at the end of 5 helps students really understand slope and connect it to real world better.
But it can actually apply to modern.
Because I don't know how many times if you show a graph that looks kind of like a hill, and you say, what do you think might be happening to this graph? They walked up the hill, they walked across the hill, they walked down the hill.
Well, and it's not just kids, because I just had somebody, as a teacher, I watched them doing professional development for somebody else, and that's exactly what they said.
Did you cringe?
Yeah, they were showing other teachers and everything.
Well,
So they had
we
clips.
do the thing in our college algebra where we use a CPR, where they have to walk along the line in terms of position, in
Right.
time. Some of them, it takes them forever to even figure out which way to walk,
Right,
because they don't think that way.
yeah, right.
Yeah, high school kids are getting to do that more. We
Yeah.
do that with ours, and they enjoy that. We do a little summer event in Richmond, and we did that. And they were getting really good. We would give them a graph, they would go model it with behavior. I had one, if your distance is the same, you might think that you stopped, that's an obvious guess. And I had a kid who said, no, we're moving in a circle around the reference point. posts are good. So kids are getting
There's,
better.
The thing about the story, I mean, we do that in our college algebra too, it's one of the very first things we do when we talk about functions. And I know that somebody could walk by that room and think we're just playing around in there, because we're having to write stories, make a graph, and write a story that explains it. That's actually really, really valuable. It's fun, they like writing a story, but it really does tell you what they know, and it helps them see what they don't know about the relationship between the verbal and the graph.
And if they can actually, when they get up and actually physically do it, you show them the graph, you have to be careful about the kid I had the one time that said you have to go quickly. So he just took off out the door and kept running. So I'm back to class.
when we first started implementing this, and I looked at this, I was like, holy cow, because, you know, I was afraid that my really lower level kids, there was no way that they were gonna get it. And they blew me out of the water. I mean, this made so much more sense to them, and they came up with the best stories. But then we had the best conversations, and then we could come back and relate all of that. So it is definitely developmentally appropriate where it's at. That's one that I would say is fantastic, and we need to leave it.
Let's write it like 3 or 4 times.
Because we like it, let's write it lots of times.
Write it really big. Big font.
Okay, that
Because you think those are really good things, and I think you'll find in a few years, your college students will be
Will do
better.
that.
Yeah, well, and that it's gonna be a good thing, I do think that's a good thing. I wanna caution though, that, you know, we need some other contexts too, not only those, but, you know, where they are doing interpreting the slope of the line, interpreting, you know, the y-intercept or whatever, I mean, those are not within those contexts, so that was the only caution I would have.
Good point.
I asked one in the building trades class when I was teaching building trades 10 years ago. And my IEP student was the first one, my trade student didn't know it. We were talking about stairs, and I said, what happens to your stairs if you add another step? Same change in the height. And the IEP student said, well, your stairs will stick out in the room further. So there's a context.
Yeah.
And the trade students are still scratching their head trying to get the line right. What's going on?
I like it. All right, so 6. Yeah, that seems important.
Yeah,
I don't
that's
like the word
something
like
that
that,
I
which seems important.
And I, you know, putting it in the context too, to do not only what they represent, but make, like we've talked about the problems, putting in context, slope, what does that mean? And if this is our slope, what does that mean in the context of the problem?
I always want to add rates to get those connections. We want to prescribe it here, but I just, because I want to understand rates and I want to emphasize that slope. We use the word slope, but we're talking
It's a
about
rate of change. And
that's what I really say, and then I say sometimes we'll just say rate, but we're talking about a rate of change.
well, and I think that's terminology we really need to emphasize. And a constant rates of change versus varying rates of change. Because when I taught calculus, that's what I always told them. I said, you've been doing calculus for a long time because you were finding rates of change. You just didn't call it that. So I think that slope equivalent with the words rates of change, I think is something that we could really emphasize, because I don't think that's language that we use in our classrooms, and I think it's if we're talking about ratios and rates earlier, that we can just continue that.
I was always writing the whole list of words that we would have in real life when we were talking about slope. Here's a whole list of words you might see when we're talking about rates of change.
Gradient, you know, that's another kids, when they talk about grade and how that's used a 10% grade when they look at that.
Yep.
Gradient, how is that used? So all of those things, I think we can go overboard with that, but I think that we need to, the constant rate of change, rates of change are just extremely important, because I know when my kids took the AP calculus test, when it said rate of change and it didn't say derivative, I said, hey, whenever they're talking about a rate of change, this is what they're talking about, and so they didn't really make that connection. So the earlier
It's all over the place.
it is, and it's not just in mathematics classes, but outside of the world. The pitch, when you talk about pitch on a roof, you know, what's the rate of change? All of
There's
those.
some vocabulary, I won't get into that.
No.
There's some vocabulary issues there.
Well, I know. But you see that in documents, yeah, exactly.
Not to write it 9,000 times in the standards or anything, but I will say that as a teacher, when you see it in the standards more often, you do tend to, oh, yeah, okay, rates change, I need to use different vocabulary, not just And so I'm not saying we put it in every sentence or in every,
Right.
part, but it does need to be in there a couple times
Right.
so, to get the teachers focused there.
Do we not, I mean, it talks here in Massachusetts about identifying the slope, and we've talked about where's it here, but do we want to have some kind of connection to the y-intercept as well,
Mhm.
the context?
Yeah, context, absolutely.
Do you think P6 sort of alludes?
Well, yeah, I mean, it talks about the roles of the parameters, but I mean, that, to me, I read that and I think, okay, you change B, what's that do to the graph? That doesn't have anything to do with context.
I just thought that we should expand that, is
Yeah.
what I put, the 8P, identified roles, but.
Connected to the context in some way. I mean, in the Common Core, it talks specifically about initial value. I know initial value is a little tricky depending on the context.
Yeah, it is.
What is your initial value? You know, it's not always the y-intercept, depending on the context.
Right.
So
Exactly.
that's the problem I have with saying initial value is it's not always the initial value, depends on the context. So,
Right, yes.
So Bob,
But it
we
could
should
be-
beware of initial values.
well, I mean, we do the thing where we try to match a line to the population of the
Right.
United States. So we have, our first graph we make has year and population. So the initial value would be in the year 0,
Right.
which is not, doesn't make any sense.
No.
You know?
No.
So in the United States, using census data, it doesn't make any
Yeah,
sense. So you have to reinitialize kind of there, so.
Alright, so those when I was teaching algebra two, where I was worried about.
Okay, and then 8P7, set up and solve linear equations and inequalities of one or two variables using algebraic methods, models, and/or graphs. I'm not sure if it is in this sentence or not, but I think that implication for systems is there.
Yes,
And I think we need to write that out a little bit
be more
more clearly.
explicit.
Yes.
And that's in,
Also, linear inequality,
8P
linear inequalities is there,
Yes.
which is not currently.
Well, and I think what we have to really think about is systems of equations. Is that appropriate for 8th grade or not, and that would be coming from.
That's another thing that I was very, very scared about when we implemented it.
Yeah.
And we did basic,
Mhm.
and we did it graphically, and we did it algebraically.
Mhm.
The kids knocked it out of the park.
Good.
I mean, they loved it.
Okay.
And they
Well,
get what it means.
the other thing is, I know we've had a discussion of, I guess it was the first time I wasn't here, but it was discussed about the importance of matrices and linear algebra. You can actually do things in 8th grade without calling them matrices and linear algebra that are the same ideas,
Same idea.
using patterns. It's really using patterns.
Right.
There's some really nice kinds of things you can do with patterns to help students see,
Mhm.
you know, basically doing matrix kind of methods with solving systems of equations that aren't that complicated.
No, no, no.
So, yeah.
Health science and ag uses they don't know what, I was helping them, I'll tell a story now, Julie. I had a student last year, the seniors were, health students were doing a pharmacy tech.
Mhm.
And so they were going on an internship. The student told me, this day I was teaching about the method they use, and I was gonna explain why it works. It's mixing things, so it's a type of system of equation. He said, the pharmacist says, here's how we do it, I don't know why it works.
Yeah.
But it's a weighted averages approach.
Yeah.
Ag uses it, health science uses it.
Right.
It's very specific, it's really for mixture problems, but it's very
Yeah,
accessible and
I
it ties several other things together.
I don't know if any of you use Ames products.
And you saw-
Have you ever used Ames?
have you
They're
seen-
fantastic materials that they have. There's books and resources, manipulatives, etc. And one of them is about approaching problems like that. Like where Ames right now is going out of business for everything but digital, so it's super sale.
Oh, good.
I mean, like 60% off on a lot of their things.
I'm gonna check.
AIMS Education,
Yeah.
wonderful sales right now.
So hit the sales.
Sorry about that, I put my little PO pitches in my hands.
But I think this, I agree with you, and when we've done professional development, this is one of the things that 8th grade teachers think after you see, you know, cause they think of, algebra 2, substitution, elimination, you know. I don't think it has to always be that way at the beginning here, cause I think you can actually use the concept of rate of change
Right.
and looking at how, and we've talked about before, comparing two linear equations or functions and how the rate of change is compared. You can use that to look at this idea of systems of equations without having to go into really heavy algebraic kinds of things.
I think some of them had real ahas and
Yes.
finally understood it and were very successful at then explaining it.
So I guess my suggestion here is, and I think it's valuable to have here, partly because of what Nancy said about how full high school algebra stuff is. This is a good thing to look at, and I think it amplifies the understanding of linear functions. But this might be a place where we need to be much more descriptive in how that might happen, without being prescriptive at least,
Right.
giving some ideas about how it could happen.
And
Right.
Now, Tiffany, I really look at something you said. I don't necessarily think we should be doing systems of inequalities here.
yeah, no, and that does scare me.
Yeah.
And
So I
even,
think that we should.
see, now I say that I love systems there, but linear inequalities, I'm not even sure, especially systems, I'm not even sure linear inequalities is,
Students have a lot of trouble. Years ago, we did a study of inequalities at our district, and that was by far, looking from 7th grade through high school, if we tracked our data, inequalities was by far the lowest of them. And so we don't do a really good job in teaching that, and so we need to really look at what we're doing and how we're doing it, because it's an important topic, but we don't seem to be doing a very good job of it. So, Julie,
What, so maybe, as to that latter, so maybe we do a little more with the inequalities, but not a system, just one.
right,
And do the graphing and that sort of thing. And I was gonna say, I think I agree. Again, not a middle school teacher, but if we can put something down, if they're able to do it, obviously it makes sense to me that if they're able to do linear equations, that they should be able to do 2 linear equations together, since you do them separately anyway, and then see where they, as long as you're doing that graphing. And I think I agree with Bob that we should tell them a little bit how to do it, and what I would say, as far as the time and how, is I would say that you do your graphing method and then the substitution method. As long as you keep reasonable numbers, you could, I'm not necessarily advocating for this, but you could stop there.
Yeah, I think I agree. I think there's another, I think building this off of context is the real key.
Yes.
If you start with, the context of 7 candy bars and 5 sodas cost you this much, and 6 or 5 candy bars and this much, and you start looking at just the common sense trade-off of what's going on, you start to see the change and the rates of change going on,
right,
and these can be solved. And what that does, it gives them the context for why they're doing this, but it also helps them understand what's going on without even having to go into at the beginning, the algebraic techniques. It's more of seeing the patterns coming. And I think there's real value. I would love for my students to have done that before I teach them techniques, because it makes sense then.
yeah.
Another thing about what I was talking about, the way we did the professional development anyway, is it's really clear for them to see equations that would have the same solutions or that have no solutions,
That
because
makes sense.
it makes sense to them when they can visualize this rather than just algebraically solving it.
Because my main concern always was the algebraic solving in middle school. It was not that they can't understand looking at graphs, looking at tables, looking at context, that I was concerned about.
we
The
started,
rigor that we do with some of them.
we started with substitution and immediately quit with substitution and went back and did, addition and multiplying, and I think that is easier for them to
grasp.
multiply first and then add, or subtract. I think that is easier for them to understand the majority than substitution.
But even that can be done in context.
Yes.
You can do, you can do things with like the example we use was like orders on for a
Right.
waiter,
Yes.
and this many of these, and this many of these cost this, and this many of these, and this many of these cost this. Well, you can add those together and get a new total. And you can subtract them and get a new total. And I mean, you're basically doing that, but it's within the context of something that makes perfect sense why you would do that.
Right.
And so it's not just some
Right.
arbitrarily picked technique that then you can go into the technique. But I mean, there's a way to present it, I think, that makes it make sense to begin with, and then you can zero in on the technique kind of stuff.
I agree with that too, but I also know that your mainstream kids still right now see a word problem and immediately
Yeah.
they're done.
Yeah.
And so sometimes it's easier to say, here's the equation of this graph, here's the equation of this graph. Why is there just one solution? And they graph them both and figure
I
it
guess
out.
what I'm saying is not just give them a word problem. I'm saying you show them a problem and you show them a new tool, which is this little, what we're gonna do here, which is really equations. It doesn't look like equations because it's 5 tacos and 4 burritos cost this much, and 3 burritos and 5 tacos cost this much.
I thought you were saying, give them the problems,
No,
have them
no,
come
no,
up
no,
with the equations and
no.
then solve it, that's
No.
scary.
I'm saying,
That's, yeah, and that's the way it's traditionally done in algebra.
no,
And we do that in algebra.
yeah, but no, that's not what I'm saying.
Okay. Okay, we're good.
Is this a pre-algebra concept, or is this solidly in an algebra?
No, this is eighth grade.
The reason I would say it's, a kind of a borderline is, because when I think of pure algebraic concepts, I think of pretty abstract stuff, and this can be pretty concrete stuff.
If it's done appropriately.
Yeah, they can look at it and they can contextualize it and it makes sense. You know, if you start talking about x squared, y cubed, z, what's that mean?
Yeah.
Yeah,
You know, we're just
exactly.
talking about this theory thing, but this is just real.
Yeah, because with the concrete, you can go to 3 variables real easily and not sweat it that bad.
Yeah.
But I would never do that
Yeah.
with an 8th grade student with letters, you know?
And I co-taught, and, because you were talking to mainstream versus an honors, and I had co-taught classes last year, so I had, if you're not familiar with that, I had like a lot of my students in there were special ed, and I had a special ed teacher in there with me, they got it. I mean, they knew what they were doing without much assistance.
It's
If they can
it's
get it,
definitely within their grasp.
I just have a question for the group. We've been going since 12:30, it's like an hour and 2:30. Do we want to take a short break and then
Can we
come
just
back?
finish this one?
That's what I was gonna ask you, we want to finish this and then come back.
I really want to finish something quickly.
Well, if we can finish these, like maybe this and then take a short break and come back.
Okay, you have to go to the bathroom, I get it.
Yeah, you got it. So, so we were systems, so we are okay with 7 with our dialogue and discussion about that?
and not systems of inequalities.
I put systems of linear equations, and then I put linear inequalities, no systems.
Right, sounds good.
But I think we also
Is that
need to
right?
add, this may be a place we need to expand,
Right.
just to give clarity.
Oh, yeah. Off to the side, I put graphs, and blah, blah. In fact, I kind of like the way, I don't think it's written clearly here, I thought you said it was written clear in the Common Core.
Can you guys convince me that middle school is mainstream middle school is the place to do linear inequalities?
Do you want us to convince you that?
Yeah, because I'm very doubtful right now. Because when I introduce it to my honors kids, we have to use a test point for quite some time before they really get where to shape.
Nothing wrong
Oh,
with
you
that.
talk to. Test on is.
Nothing wrong with test point,
Right,
that's what I did in
right.
college.
I do too.
But I'm saying I have to pull teeth enough with them to get them to really truly understand where to shade and not just memorizing a rule. And even once they say above the line, below the line, they confuse themselves sometimes depending on the slope of the line.
So are you talking now with linear inequalities, so you're talking with 2 variables?
Yes.
That's because I just want to make sure.
That's,
Because I thought
that's
that-
exactly how I teach it as a test
Me
point.
too. That's all I
Right.
teach.
So, I mean, it's the make sense way to do it.
It is, but even when I teach that with the honors kids, then we do the test point. Okay, is that a true statement? No, all right, so what does that mean? You shave this one, and it's like pulling teeth, so it can mainstream, is that appropriate for
Hey,
mainstream?
I'm
I
gonna
guess
go
I-
with Tiffany. I'm gonna go with, on a number line, we're seventh
Yeah,
grading it or
Number
whatever.
line, I think is fine.
I
Or
think that's fine
plain
too, I'm
high
talking
school
about,
in it.
And I-
my question is for you, have you ever tried, because it works well with me, with my kids, where you get it in the form of y is greater than, or whatever symbol you've got, you know, your 2x plus b, therefore your y is bigger than your line, it's above your line,
Mhm.
where y is less than, do they still have?
yeah,
shading?
because depending on which way the line
Yeah.
is looking, do they think,
Depends on
if it's a negative slope or a positive
Well,
slope?
but you still always have above the line and below the
I
line.
know,
Yeah.
they don't see it.
They don't.
She's right, I mean,
They
I'm
do
not-
not see it.
Well, that's what I do, and I always have great
Yeah, but
successes
what-
with it.
But your
But what
kids are
grade
older.
level, but what grade level?
It's
They're
college.
older.
Yeah,
Yeah,
so
it's-
there's a big
it's
difference
different.
between the kids able to reason at that level than what she's talking about is
Yeah,
eighth
and
grade.
that's probably.
And I think part of it goes back into eighth grade when we saw linear inequalities in one variable, that maybe the test point condition, I'm not sure that we do it correctly
Yeah,
there.
yeah.
So it is like really developing the concept with one variable and how do the kids decide which way to shade. I think unfortunately a lot of times we just tell them to shade, always have the variable on the left and you shade whatever direction the arrow's pointing.
Yeah.
Rather than really conceptually understand, and I think.
But I've even had kids really good with that, and they could graph it on a number line, no matter which side the variable was on,
Mhm.
and then you throw them, and they have to put it on a
It's much more
coordinate
abstract,
grid.
there's no question
And
about
I
that.
think inequalities themselves are more
I
abstract
agree
than
with
those
wholeheartedly.
light bulbs just
But you're
have
okay
it.
with
always.
inequalities on the number line in seventh grade?
Absolutely, absolutely. I'm just worried about a linear inequality on a coordinate grid with my mainstream eighth graders. My honors kids can get it.
And that's something that we really need to look at and reflect on review.
We'll do one variable inequalities in seventh grade,
I can do that
solve and graph.
Maybe that's a,
on a number line.
maybe that's a plus for the advance.
I think it's definitely appropriate for your honors kids. I just, and you know, I'm
What about
open
eighth
to be
grade?
convinced otherwise, but I think for eighth grade, I don't know.
I think it's okay if they don't do it.
Yeah,
I
I
think
think,
so too.
I think we
I
pass
think
them.
it's okay.
Yeah, I
think
We
so.
go like that,
Pass them.
yeah.
That they have a really good firm foundation of graphing period, and we can, you know, in high school they can set up.
Okay, so we're at APA.
Mhm.
Oh, blah, blah, blah.
Hey, maybe your circle jerk's coming back here.
I mean, that's,
Pretty straightforward.
but it's, in a sense, it's slope again, in a sense, it's proportional reasoning, and I mean, it's kind of things we've talked about in various forms, and we, of course, we have the pictures, graphs, charts, equations thing again. I don't know, is there anything new there?
No.
I just think it's a preamble to grammar change in high school is all
I
it is.
hate the wording.
So yeah, we talked about how the square affects everything more than just the straight line, and we talked about when you start squaring it, doing what
Yeah.
happens. Is that what they're referring to, or are they referring to something else?
That's pretty hard if we don't know what they're referring
That's what I'm
Yeah.
saying. Standard gets
They-
it.
Well, I don't think we
It's
have
not
to we haven't talked about the fact that if you're scoring a variable, it has a bigger impact, right, than if it's just,
Right.
Yeah.
No,
so if that's what they're referring to, then I think.
Except we did throw in there, when we look at linear, to make sure to have nonlinear, that's a great example of a nonlinear.
Mhm.
I don't like this standard.
No, I mean,
Just
not
put
the way
a
it's
question
written
mark
down.
by it. Is that okay?
Yeah.
Yeah.
And then,
Wait, why don't you like it? Just confusing or unnecessary or?
I would say mostly unnecessary, I mean, we've done most of everything here.
I think it fits in other places,
Right.
it's.
It's not that it's not important, but we've done it in other places, and, you know, we
It's
just
kind
need,
of like one.
And we will do more with it later,
yes.
Yeah.
because you're gonna look at, you know, quadratic relationships.
Right.
Okay, use linear.
Well, I
Right,
think
no.
that's its real downside, is that you're talking about slope again, but a
Yes.
teacher that's looking at this and thinking, well, how is this,
Right.
it must be something different, unless,
Yes.
or they wouldn't have put it there, and I think
Yes.
that's maybe the
That's
danger.
very true.
is
Yeah,
that
very much, I agree.
Because obviously what it's saying, understanding that a change in one results in a change in the other, and looking at the character of that change, I think all of us agree that that is super important. It's just, maybe this isn't the way to do it.
Right.
Is that right?
Yeah, I think we all agree that that's important, but it's probably been taken care of or will be taken care of within the context of this meeting.
And 9, we're back to the proportional relationships, you know. And one thing that I don't think that a lot of Missouri teachers understand, a lot of teachers in general, I even went to a national NCTM Institute on algebraic reasoning, is what a proportional relationship is. I think that all linear equations, or all linear things are proportional.
Yes.
And I do think that that is clarified more in what we're using now. I understand it's than it is here, but I think it should be emphasized that it does have to go through that origin.
Right.
And I think that's something we could clarify a little bit more for them to make them understand what we mean by proportional relationship.
I totally agree.
Yeah, and I will give you that one. I think talking about that constant of proportionality, and I wouldn't mind using some of the symbols for proportionality. I guess I'm not committed to that. I'm not gonna advocate for that necessarily, but if we did, I think that would probably be okay.
Guess what time it is, Kathy?
Almost fine.
Yeah, we talked about 10, that's it.
I think we have, I think it's pretty much already been discussed.
There.
Alright.
Okay, so what do we have, Kathy, 5 minutes, 10 minutes?
Yeah,
What is
what do you think, 5 minutes? Is 5 minutes enough, is all I need?
Yes, because if we say 5, you'll take 7.
Okay, so let's approximately 10 till.
Cause you know, I almost got up with you early to start.
Well, I know you did, because you said go.
So the thing we were talking about is
And I didn't know how to look right now. What's that urinal?
that makes me feel better.
I had texted Jeremy this morning, question, he said, do you have Karen's number? And I went, no. Well, you need Karen's number. So can I text you so you'll have mine? Okay.
K through 2 got started.
Did
And
they?
K through 5 got started.
They did?
2:25, yeah.
Oh dear.
I guess the rain and everything brought some of theirs in May, but I don't know.
So it must still be raining
Oh,
somewhere, or,
now.
no, it did though, did it again?
Yeah, I think it did.
Cause it was, I saw the lightning. Is it supposed to rain tomorrow?
No, who's driving home
No. But it's supposed to be nice and cold, high of 60.
Jamie,
Yeah, I
you driving
heard
home
15.
tonight?
Ooh,
Sorry.
it's
No.
almost 2.5 hours.
Wow.
Yeah.
I didn't realize it was that far. I'm geographically challenged.
Well, that's why you're in a math committee and not social studies.
I'm challenged in a lot of things, so issues.
Get it? Okay. Well, and I'm notorious for typing in the wrong.
And tell me again how old your kids are.
I have a child that's in 2nd grade, 1st grade, and almost 5.
All right, so you have them close together, didn't you?
Yeah,
Plan?
I haven't been married very long, so we saw what we could get
Let's
done.
do it. You know, I have 3 kids. The first 2 are 3.5 years apart, and the second 2 are 4.5 years apart. And in between number 2 and number 3, my sister-in-law had 3 kids. But yeah, we took 2 different approaches.
Yeah, I got it done pretty quick.
You know, I loved it for my reasons, and she loved it for her reasons. Like, and her kids are so close, and they were just raised so close to her.
Like anything else, there's a lot of good things about it. But there's some things that sometimes I remember things of a child being young and realize I've mixed the kids up because it all happened at the same time.
Now, one of the things for her, her older child was kind of developmentally delayed, and the next one was ready to move on, and she didn't want Corey passing Brian, and so kind of just dealing with that
That would be
without,
difficult.
without making without overlooking the second one's needs, but not making the first one feel bad. That was tough for her.
I bet.
Nancy, and you guys, one of the things they left here is a supplies list of things we need for tomorrow. So before we leave, we need to make sure that we wanna do that carports, things like that.
Not too very close.
That's what I'm asking.
No, I took note of it. That was my personal opinion, but I'm not a neighbor.
I know you're not.
So everybody can't see how much I've used.
Did they say that the fair pool last year is it decent?
I stay there once, and it's fine. I usually stay where I'm staying this time is at the Comfort Inn, and the reason is because they're inexpensive and they accept you as state government rate, and they don't charge you tax.
My district.
Well, money on you.
My district, but I was very fortunate.
That is nice, they're paid for it.
My husband watched me book her.
Yeah,
You know,
exactly.
I didn't know if they were going to, and he's like, we'll book your hotel. And I was like, okay.
And when I say good for you.
Yeah.
I work in a very, very supportive, amazing.
That's right.
Did your superintendent tell you I met him?
No, I haven't talked to him, but he emailed me, when he found out that I was on the committee.
I met him this past weekend at the
Oh.
MFBA conference. I happened to be sitting in the lobby with my husband for our room to be ready, and he sat down, I said, who's that saying Nixon? It was such a nice time.
What's his name?
He's, Stephen Kleinsmith.
Kleinsmith.
He is an amazing superintendent. I mean,
Like,
he is. He's so supportive, he's so involved. I mean, both of his boys have gone through the district. His wife's the counselor at the high school, but I mean, he's just amazing. He will fight for kids all day long.
So the board members came by and he said, she knows good.
We had some really good mix of students at our math contest Saturday.
Good.
Really, we had one that did really well.
Was it high school or?
High school, yeah.
Christian
Well,
Barker.
what's his name?
Christian Barker.
Well, I don't think that was his name. The one I'm thinking of was, he's Oriental. What was his name?
I don't know, we're big enough, I might not have one.
Very, very good. He did well.
Is anyone opposed to K through 5 using the same Dropbox as we do? They'd like invitations, and it's fine with me.
I think they need it.
Fine with me, yeah.
It's pretty cool. And
Well,
then
yeah.
what I'll do, I already added a folder that said agendas, and I added one that said minutes, or what Ann officially does. So we have one for notes, then we have one for agendas from Kathy,
Yeah.
right? And we have one for minutes from Ann, and then I'll make a separate one that says K through 5, or I'll put,
There
I think
is
you
a
had a
K
K
file.
through 5 one.
I thought I did, but
I think it's
Oh,
in.
no, I think Jay put it in earlier.
I can put a 6 through 12 miscellaneous for all those kind of other things. I have one for Massachusetts and trying to define it so it's easy for us to find, but like Lisa had sent me something early on, before our last meeting, in between meeting 1 and 2, and I put it in there, but I might put that like in a miscellaneous folder, because anything else that I was sent in between meetings, I didn't put in because 2 reasons, and I'm not trying to be rude. I didn't want to be everyone's secretary, because what if I forgot one person's thing and then they thought I was overlooking them? And 2, I thought the group should agree that it went in the folder.
Yeah, because I think we want main documents, not, the main documents, because it can get really cluttered with a lot of different stuff, so, yeah, I think that.
Is that all right?
Yeah.
Then would it, if we have other documents that we think people might be interested in, but do we just share them by email with each other? Is that the best way to do it?
I'm fine with that.
And I'm okay with creating a folder that says,
Miscellaneous.
other information. The thing is, we gotta decide about how to do it, because I was gonna make them view only also, because I told you some people don't
Yeah.
recognize that if you take something out,
You take
you
it out
have to
for
put
all.
it back in, or it's gone for everyone, or they alter it and put it back in. Do you know what I mean? That's why most of the stuff in there is PDF.
Yeah.
I left our informational sheet in there as a Word doc because names are still changing and things,
Yeah.
you know. And I'll do whatever you want. It's truly about us sharing things. You tell me what you want, and I'll try to set it up.
It sounds like that's a poor limitation of Dropbox. It's like a library where there's only one book and only one person can take the book out at a time.
Anybody can access
You can
it,
access it.
so we could all have the same document open at once.
Yes.
Oh,
Right.
But if you pull it out of
If she-
Dropbox,
You
to
pull
like
it out
save it
from
on your
everybody.
computer,
She
and
gives,
then you can
she
have that.
gives us the ability to put in, then we can take out, we leave it out, it's gone.
It's going
This is what I would recommend you do. This is what I do with, like Kathy shared one with me, but I didn't want to alter Kathy's. I just highlight the folder and copy the folder,
Okay.
and then I have everything that's in that Dropbox, and if I want to change it, I can, without changing Kathy's Dropbox. Because she shared some things with, from Mars or Shell, or
Yeah,
whatever it was.
yeah.
So I take their folders and I copy it, and out to the side on the, it'll say copy, in this case HB1490, and I'll put a date out to the side that I copied it, so I'll know anything added after that, that maybe in 3 weeks I need to copy it again and delete the old one.
And the thing is that too, that if you don't set up some of the rights, what happens is somebody changes a document, didn't mean to change it for everybody, but changed it for everybody, or they pull and they drag it out. Anything
Just
you
save
want, anything in that you want in there, if you copy it, you can paste it someplace else. You can open it, you just can't remove it or put it in. And I think it's better to have a filter for one person to be, one or two people to be filtering in. But like what we could say is, hey, I have this great document, should I put it in the folder, can somebody put it in the folder? Maybe we can even talk about it here, what are some things before we leave that we wanna share and have? But one thing we don't want Nancy to do is everybody send her 50 documents to put in.
Sure.
And honestly, I would do it, I just don't want to overlook anyone, and
Right.
someone to take it personally, or,
Right.
you
That's
know,
why it's easier for you to do it while you're here.
I'll put in anything you want.
And what we
Well,
will
maybe
say,
that's the way to do it, because like I was looking at the National Mathematics Advisory Panel
Right.
recommendations, and I thought those would be something useful for the group to look at.
right, I read those.
And I don't want, I don't want Nancy to be the secretary either, so what's the best method to share?
But I think like some of those generic things, like you're saying,
That you're bringing.
that, yeah, if we have any neighbor, yeah, or just if we bring it, just say it at a meeting and we all agree, then she'll put it in, there's no question about that.
You said person, or
Yeah.
she can do it, so.
Yeah, so if we have ideas like that, because I agree, the National Math Advisory Panel is a really good one to look at.
If you would either send me a link to it, I
Okay.
will put it, print it as a PDF on my computer and just put it in there. That's okay with the group?
Yeah,
Okay.
I think so,
Okay,
yeah, I think so. Okay, it's almost 3:00.
let's roll.
Well, let's talk about what we need to get done before, well, but there are a couple of other little quick things. One is we wanna make sure at the end of the day, we don't wanna take much time, but talk about where we're at and what we wanna try to get accomplished tomorrow. And also, there's this little list that I've gotten that was handed out here, that supply request list, that what are the things we need for tomorrow when we come back, like power strips, for people to plug into. So we wanna make sure, maybe take the last couple of minutes of the meeting to put those items down so that we have the power strips and things like that we need to have when we come back, so. Just take like a couple minutes at the end to do that, so I just wanted to let everybody know that. So are we ready, are we ready to roll? Okay, let's get her on the
Do you
roll.
need this do you need a timekeeper?
If you can kind of keep, yeah, so we quit, like, let's say at least 5 minutes before 4, that, or 10 minutes before 4, we can come up with those things. So if somebody would let me know, like 10 to 4, that would be great. Okay, so we finished number on the grade, so then the next one to look at. We're doing patterns, is jump. And if I remember right, wasn't there a discussion about 6th grade geometry and moving some of the 6th grade geometry to here?
Transformation.
Yeah, transformations.
So. I guess the big one that teachers were really afraid of in Common Core was the Pythagorean proof of the Pythagorean theorem, which doesn't appear, yeah, it does. No, it says demonstrating an understanding of the Pythagorean theorem applied. So I guess the question is, do we think they need to understand proof of it or understand it and apply it?
I like understanding apply, and I do like that we specify including finding distances on the coordinate plan.
Yes.
I think that would take a lot of fear away from a lot of eighth grade teachers if we could
We,
Although
explain and prove.
I would go around and do my
Me too.
origami.
Of course you are.
and we
You're
do,
the
we do an activity in eighth grade now where the kids come up with the relationship. But truly, it's only the higher kids in my regular eighth grade classes that can really come up with it and understand it.
And I think that the really main thing is we don't want people just to hand them the formula for the Pythagorean theorem. And, you know, I like that this says Pythagorean theorem. I really hate it when it says a squared plus b squared equals c squared. I want to get rid of that. I wish that had never appeared. Because now it doesn't matter what triangle you have, a squared plus b squared plus is equal to c squared, whether c is the hypotenuse or not. So there are a lot of issues there. I like, Nancy, what you brought up about finding the distance on a coordinate plane, because that's where our kids really need to, why do we even have the distance formula in geometry? We really don't need that. What we need to know is they need to understand that it's just an application of the Pythagorean theorem. Let's not give them another formula to memorize. Let's make them really understand the Pythagorean theorem and how to apply it. And not, we get our kids so jumbled with so many different formulas they don't know what to use. And I don't know how many teachers don't even know that define the distance between 2 points, you can just apply the Pythagorean theorem.
So we don't need, a proof per
Right.
se. Although we hope that we're all doing some understanding type
Yes.
things.
It could be little informal proofs.
Right, any formal proof.
Building.
They want to do that.
Because when they say explain to prove, there are
No.
many proofs of the Pythagorean theorem,
Exactly.
most of which are above, use things that eighth graders wouldn't really.
So,
And I think one of the important things about that statement, we're talking about the common core, and its converse.
Yes.
That's important.
That's important, we talk about that converse.
Right, the converse of the Pythagorean theorem.
Do you guys agree with that?
Yeah.
It was just the explain and proof that's
Yeah.
very difficult for all
Yes.
eighth grades.
Exactly, so
So most.
I put
Yes.
understand and apply, and it already says solutions of problems. I put down, coordinate plane with distance and, the converse, and those are the things we'll work into those
Yeah.
standards that
I
apply
agree.
to Pythagorean.
I do really like that, and it probably means it the same in both. The Massachusetts one says in solution of problems, which I think we've decided is probably those real world, but it says it specifically, in the current standards where it says to determine unknown side lengths and right triangles in real world and mathematical problems in 2 and 3 dimensions. And so I really like that.
I like that you said that, because, the 3 dimensions is pretty new for
Yeah.
people.
It
But
is.
it's pretty cool.
It is
when
really
they
cool.
actually start connecting.
It is really cool.
And eighth graders at 7th, 8th, sorry.
Thank
The 3 dimension, that's okay with them?
We just started.
Okay.
So maybe, coming back in a couple of weeks.
I may say, never
No
mind.
way.
Now, last year, we started implementing things last year in my
Right.
district, but we did not, we focused more on coming up with the Pythagorean theorem, and we did 2-dimensional. We did not have 3-dimensional last year, so.
You've been 3-dimensional with what?
Pythagorean theorem.
Yeah, we did not add 3-dimensional in 8th grade last year. We were coming up with the formula and discovering the relationship, and so it took us a good 3 or 4 days to discover that relationship.
Sure.
And so then we said, never mind, we'll get 3-dimensional next year.
I did that with a house with a hip roof.
Mhm.
You have that 3-dimensional and hip wrap roof. And sent the high school students back and said, ask your high school teacher. High school teachers aren't familiar with that. Not that it's hard, it's just.
Right.
So I didn't catch the first part because I hadn't realized they were doing that. I
Okay,
think it's
so,
pretty fun.
so part of the same will be with the hip roof. Got it.
Is it, do you do it with the slant height of the column? Is that
We don't.
the way that you're?
Last
doing
year,
it?
all we did-
No, just coming up with problems where it's set, where
Honestly,
they're,
we didn't look into that too much last year, so I'm
The
not sure.
3 dimensions,
how you're doing. Well, I'm just trying to figure out what that would be.
for instance, I'm just making this up, okay? If there were a security light up there, how far would it reach?
So just the
The
context
the
is three-dimensional.
Yes.
The
Yes.
title itself
Right.
is still two-dimensional.
Right.
Yeah.
Yes.
We
So
get
that's
like
why
a
I think the
suitcase.
plan type of poem, it's that, that's,
Right.
I was trying.
She stopped talking, Mr.
And like when we had it in a suitcase last year, we were talking about, does this fishing pole fit in this size suitcase or something like that? And we gave them the dimensions, and all of the kids immediately went to the length and width and completely ignored the height. At
One-
that point, that was not a battle we were fighting, because we
One
were just glad. we
One of
did
the
this.
examples on the praxis that we've always used is, you know, you've got a rectangular prism, and you know the dimensions of the main big diagonal of it, which means you have to do Pythagorean here twice.
Right,
Once on the base.
right. Yeah, I like that three-dimensional. perspective.
I can focus more on that though, if I don't have to explain the proof.
Yes, exactly, absolutely.
See if the fishing pole fits.
That's right.
Your plane is so clear now.
I'm ready to teach all of you.
There you go.
Please no.
Okay, okay, let's start down just this list in
Right,
Massachusetts. HB1
right.
is about the number of sides and the sum of the interior and exterior.
Did we talk about that already?
We talked about interior, didn't we?
Only
Didn't we? Yeah.
And I think before, wasn't it just up to a certain
Six.
six? Yeah, because it was like, they said 8 and we said 6, and so this should be generalized. Is this the appropriate one in general?
That concept should not be that difficult.
Okay, let's say yay and
Yeah.
jump on,
Yeah.
we may reword it or expand on it a little bit, but is that all right?
Yeah.
Okay.
What about the second one?
That's very,
Congruence and similarity.
It always seems
it's
hard.
very difficult for students,
I
and
don't know.
that's what I was just asking her about. I don't understand why, especially if we are spending so much time with ratios and proportions and all of that thing. I don't understand why this is such a difficult concept for them, but if the shapes that you have are drawn with the same orientation, they're good. You can rotate one of those shapes, or you can flip it, forget it.
That's where the, I mean, the Common Core does make it. I don't know if you want to say prescriptive, but it does, this is a place where it does say, look at congruence in terms of transformations. So that's very more specific than what this says.
Well,
And you could do similarity as well, so. Because I mean, HG2 says, understand that a two-dimensional figure is congruent to another if the second can be obtained from the first class rotations, reflections, translations.
But that sequence of transformations is difficult for them to see. It's difficult for me to teach.
when I was looking at this one, I was thinking more of the similarity and thinking of it more in 7th grade for scaling up and scaling down and talking about sides, and it fits in well with a lot of real world or contextual or whatever problems.
Proportional.
Yeah, I saw this more fitting in 7th grade, just to talk about what is similarity and congruence, and if you know something's congruent, what can you say about them, more than proving congruence or proving similarity.
And that's the way I have, because I've had a lot of people ask me about that one.
It's not,
And I think the intent was from Common Core, of course, I have no idea. And I think what they were trying to do was say, 8th graders need to understand what it means to be congruent and similar without side, angle, side,
Yes,
without
I think so.
proof. It's about, can you see that if you pick this one up and move it, it's the same as that one? That's not, a lot of people haven't interpreted it that way, and I can see why not. It seems like it's a whole set of things you have to teach them about how you move this. I don't think that's what they meant, so I'm kind of with Nancy, is I think it's more about what does it mean to be congruent,
Right.
what does it mean to be similar, and that's okay in seventh grade.
I think for seventh grade, we can work with what is it and how do you scale and how do you find those different links?
I'm gonna see my
And-
hands.
Yes, so I think in seventh grade, that would be our application of this. In eighth grade, once again, I think it fits more with what we said, the transformational geometry, we were going to move there.
And it's really important when they rotate the shape, that they realize that it remains the same. 'Cause-
Preserves
Yeah,
congruence.
because I will tell you that in my calculus class one year, when we were trying to use the trapezoid rule of approximation of the area of the curve, not one single kid recognized that it was a trapezoid under there because of the direction of the shape. Not a single kid. Out of 33 advanced students, not one did. And they said it's not a trapezoid. I said, yes, it is. And so I just took it and rotated it, and they go, oh yeah, now it is.
It's not a square, it's a diamond. That idea.
But part of that goes back to elementary school as well, because
Yes.
they don't recognize rectangles, or they don't recognize triangles if they're slightly turned or rotated. They don't recognize a right triangle if the orientation is different.
So the question is, do we want to prescribe the way Common Core does, that by when trying to explain what it means to be congruent, we're saying this about transformations, or do we want to say it a different way?
This is what I'd like to do. I'd like to take this one and put it in seventh grade as far as lines.
Right.
Yes.
The Massachusetts one.
Mhm.
Yeah.
Yes, yes. And then, and maybe not word it that exact way, however we're wording it, but the idea that kids will know things about shapes when they're congruent or they're similar, and find links and find angle measures, etc. As far as the relating it to transformational geometry in eighth grade, I think somewhere we need to mention that kids need to know those properties, but I don't know that we have to prescribe it the way it is in the Common Core.
I agree. That's kind of what I think it needs to, I think I know what they meant to do here, but I think they made it so prescriptive, it sounds like a whole new thing.
Yeah.
And I don't think
It
it
does
should
sound
be.
like a new thing. It
Yes.
sounds like,
It
okay,
does.
here's my shape and here's my shape. What transformations did I go through? So I rotated 90 degrees clockwise, and then I had a vertical translation of, and that's how I'm reading it.
Yeah, I've heard people call this proof by transformation. I don't think that's what they meant, and that, even if it is, that's not what we should do, I don't think.
Right.
Even if it is what they meant, I don't know.
And Bob, are you talking about?
Well, let's make it
and four?
Yes, AG2.
Two is congruence and four is
Four is
similarity.
similarity, yeah.
Okay. So are you?
I was talking
both of
about
those?
two, but I think it applies to both of them.
Well, because
Well, no, wait a minute. Maybe not four.
Maybe 6 or 7.
we've already crossed off part of six.
Here's the other question
Yes.
of that. Because we do emphasize when we teach transformations, when we teach translations, rotations, reflections, that you're not changing your shape. In GLEs, dilations were not considered a transformation because it changed the size of your shape.
But it is.
It is.
But it wasn't, and now it is. And so we used to just say, if it's a transformation, it's not changing, so it's gonna be congruent, because that's the way that it was worded in GLEs, which it's not now.
I guess I still, even on four, it still sounds like a thing that I don't think we're talking about, because it says, the last thing says, given two similar dimensional figures, two similar two-dimensional figures, describe a sequence that exhibits a similarity between them. I don't really care if they can describe a sequence. I want them to know how to know they are similar, and what that tells them if they
And
are.
if they are similar,
What that tells you, right? But I don't really care about the sequence of transformations to get there, do I?
no, in fact, well, I don't know if you do. But I would say that this is a place where we could, not get prescriptive to tell them how to teach it, but to tell them what we mean by that.
Yeah.
For example, the length of the sides of the, how they compare and the angles and things like that. We're not telling them how to teach it, we're telling them what we want the kid to know at the end.
Yes, yes. So in that regard, I think, yes, 2 and 4, I don't like 2 and 4 in Common Core.
Would everyone look at this to make sure 2 and 4?
One thing I thought, that I have read those, is I thought that's maybe leading to, when you're looking at graphing functions and you're talking about the parameter changes in functions. And I thought this is some background that a teacher doing that can refer to.
Yeah, it is, that's true.
It is, but
I'm
I
not sure
don't
that it's,
see-
But it's,
They're
but it's
not
much
ready for
easier
it.
to prescribe when you have a coordinate plane what the movement is than it is when you're in space.
oh, yeah.
even when you do it on a coordinate plane, the fact that they have to think that far ahead, because they have to visualize, I mean, if they have a manipulative in their hand that they can rotate and slide, great. But if they don't, and they have to visualize what it would look like if I rotated it this way, and then if I moved it down here. the
I'm not
majority of
saying it
your-
ought to be there, I'm just saying I think that's
I-
something
Okay.
thinking.
Yeah.
What do you think of, even if it's just for transformation, so that they're not doing the rotations, because rotations is the one that drives
Yeah.
them
Yes,
crazy, right?
absolutely.
What do you think about them having to write the series as in, you know, x plus 3, y minus 2,
Using-
to show the movement?
We do that.
But what about putting that in here? Maybe not the rotations,
Yeah, no,
because I don't think they'll give the I really don't think they're ready for it.
Not your average student.
they don't.
Correct.
You can-
And since we're talking about something that we want all the kiddos to do, I don't think that that would be really fair to a lot of kids if we put that in here, because I don't think they're ready.
No.
But I do think they're ready for transformations.
Yes.
The
And I think
translation,
they're
yeah.
ready for reflections.
translations and
So is
reflections,
that
they
what
can
the
do that,
Common
yeah.
Core Standard 3 is alluding to?
So-
Violations, translations.
Yes.
Using coordinates?
Yes.
But I do think, as far as rotations go, they just memorize it because it doesn't make sense to them. And then when you say when it rotates around the origin as opposed to rotating around a different point, they struggle with that.
I think we put rotations in there. I really think at this point that we should only use the origin.
That's what
I
we
do.
do.
Rotations
That's what we
around the
do.
origin, rotations about the origin.
We don't do anything else.
If you guys would jump ahead for just a second and look at 10G9 and see where they're going with this concept
And which one?
in
In
Massachusetts,
Massachusetts.
and just make sure that you haven't left too much there. And where are we at? 10G9.
What page?
What page is that?
I think it's 74.
Oh, I'm sorry.
There, 74.
Yeah, there it is.
That's where they're picking it, those concepts up with the rotation and the translation and the reflections. Can you cover it all in 10 if they haven't had some introduction in here?
Well, I think what we're saying, I mean, what I hear we're saying is that we want them to do the transformational geometry. We want them to reflect and rotate and things, but do they have to tell the series of moves to get there? That's hard for a kid to say, first I rotated it 60 degrees, then I moved it to the right 3 places and down 4 places. That's really hard for at least my students to have done.
Yes.
But I think that if we, and it's hard for them also to write a rule that says how the change is for a rotation,
Right.
but not for a translation or a reflection.
I think
So I
translations
think
and
that-
reflections are full fair game. I think they can do that. I think you're right with rotations. That's a whole other piece.
Yeah, so I think for reflections and translations, that they can write rules.
And even dilations,
Oh,
Yes.
dilations, thank you.
Dilations, I can.
but rotations, you know, and we
And,
don't,
and I think that they should be able to identify that it's a rotation
Yeah, identify.
only about the origin.
and are you saying 90, 180? Or is it, you know, like a rotation 90 degrees or 180 degrees?
Yeah, no,
Clockwise or counterclockwise,
or
no
even 270.
funky 60-degree rotations.
I would say 90, 90, 180, 270.
Yeah.
Or 90
Clockwise
clockwise,
and 90
counterclockwise.
That's,
Okay,
that's reasonable.
there's still a separate issue to me though, I agree with what you said, I'm good with that. That's about transformation, but we're still in 8th grade in Massachusetts, there's the idea, and in Common Core, about defining what it means to be congruent and similar.
Right.
Or what that means to be congruent and similar. Are you, I mean, I I still think we need, I don't want congruence to be defined only by, no, I don't mind it to be defined by transformation, I just don't want it to be, that you're trying to prove congruence by transformation. You see what I'm saying?
I thought we kind of had
Did
some.
we need, okay, we got
Putting
that.
it in seventh grade. was
I
what
thought
she
we were
talked
still
about.
talking about that too, so.
I wasn't for a change, but,
My wife and I talk about different things all the time. We got one conversation.
I can imagine Betty talking about congruence in education.
No, hers is a different one.
What do you think about what Bob's saying about that? I don't know, I just.
I
don't
thought
think
we were
could
thinking
do it.
maybe it fit better in seventh grade where it seems to be heavy proportional.
That's fine, I'm okay with that. I just don't like the way Common Core makes it out, defining. It almost sounds like a proof, the way they read it.
What I'm saying, Tiffany, is, I'm saying for them to, the similarity and stuff goes in seventh grade and congruence and what you can tell about the next shape if you know they're congruent or similarity. But as far as what Bob's saying about prescribing what the moves were and all that, I thought that we just kind of said,
No,
theirs.
okay,
Yeah, I agree.
Is that all right?
I'm good.
Yes.
That was 2 and 4, we kind of just said, eh.
Okay.
So is 4 gone, or is that also just basic, like, cause I know we said 2 is now in 7. So is 4 also covered in 7?
Actually, I think, I understood it to kind of say 2 and 4 in Common Core were gone.
Oh,
Because
okay,
Yeah,
okay, sorry.
Common Core were gone. Yeah, and that 3, what is sort of like the similarity stuff. I mean, that, the similarity stuff in 2 in Massachusetts was gonna go to 7th grade.
Oh, okay.
And
Is that right?
still,
That's what I thought, yes.
What'd you say, Captain?
and still when we're,
Yes.
and still when we're describing the effect of dilations and translations of notations on two-dimensional figures, we still use those terms, or I would hope that we would still use those terms when you translate an object or a shape, it's congruent to the original.
Yeah.
Your end product is congruent, and when you dilate,
Sure,
it's similar,
sure.
but not necessarily through a series.
Right.
It's the focus is not on describing the movement.
Correct,
Focus is on congruence there.
correct.
Okey doke, so that puts us down to number 5. Is that right?
Yes.
Oh, did we say 3?
Did we do
already
anything
talked
with
about
3? No, we didn't talk about 3.
3.
The transversal.
I think that could be 7.
I don't see that in 8th grade Common Core.
Yes.
Yes, transversal,
Where's it at?
it's standard 5, geometry 5,
In eighth.
8th grade.
Yep, there it is, okay.
We're gonna leave it 8?
It looks about the same. doesn't it?
Okay, so we'll leave it 8.
So we're down to 5 now?
Conjectures.
That's very, that's very, very. And what kind of energy forms?
Does anybody do compass stuff in construction in 8th grade?
One of the things that you teach kids somewhere in middle school, Bob, is that the sum of 2 sides of a triangle have to be greater than the 3rd side. You know what I'm talking about?
Triangle inequality.
Mhm. So you teach them things like that, and I use compasses. So
I don't,
I'm not sure how we test it, but once again, I know I'm not supposed to be thinking about just about tests, but I do think that they should have had a construction tool in their hand before they leave middle
Yes.
I do.
Make them use a ruler, I think we should make them use a compass.
Absolutely, absolutely.
Or whatever that
Well, we
circle
asked
thing you call.
Yeah,
Yeah.
it's a compass. And
We
yeah.
asked them to use a protractor to measure angles, so it seems like we could use a compass to draw a circle with a 4-inch radius or something.
And all these children running around with sharp
Safety
pointed
compass.
things. I'm just
Now,
joking.
you're getting another one.
Safety compass. That's right.
Safety compass, I love those things.
I mean, that's, you know, there also is, of course, technological ways of doing construction too, so that's what I wanted.
Wouldn't that be something below 8th grade though? Like, couldn't they use circle, whenever we introduce circles, or whenever we talk about the different parts of circles, even though we're not doing formulas or anything yet, couldn't that be a good time to learn how to construct circles of varying sizes with the compass or something? I just,
So
I
when
don't know,
we're
it
doing
seems like a waste of time in
circumference
8th grade.
and radius.
So 7th grade, is it something that you think should be in a 7th grade or prior to that or 6th grade?
Unless, wherever we are putting constructing circle graphs, you could do it one there.
Well, don't you think it depends on what we're testing and what we're drawing? I mean, cause if we're gonna talk about bisecting angles or something and they don't have a clue what that means, it's not gonna do, I mean, I think it depends on what the rest of the sentence means on where we wanna put it.
I think that this is a 7th grade thing, I do.
And I think we decide what it means and make it clear and put it where we think it should go, yeah.
I don't know about that.
Fine.
So Bob, yeah, because I saw you shaking.
Well, I mean, I just don't know what, there's so many alternative ways to do construction. I don't know, do we wanna prescribe to use an actual physical compass?
What I think of is, I do think that they should have the tool in their hand. I think this could be, what we used to do, say, non-test item. Or just something so that they have used those tools, technology or the physical thing, before they get out of middle school.
Yeah.
Where's
My
that
elementary teachers, all the construction stuff we do is on computer.
You know, some school districts are gonna have that capability and some are not. And so,
I think we need to note that.
On Common Core, on page 50, they have draw compasses, they have freehand with ruler and protractor, and with technology, geometric shapes. It's number 2 at the top of page 50.
so why can't we put or technology?
Yeah,
Yeah, that's what I'm thinking.
and it's in 7th grade here.
It's in 7th grade, yeah.
Okay.
Oh, see,
Which is what we were just talking about.
there we go.
So that would
Yeah,
probably be
or.
very appropriate to say or instead
I'm
of
okay
or.
with that.
Yes.
Otherwise, I was gonna go buy stock in compass.
It is also,
And the compass was technology.
It was, yeah.
well,
Like
This
it's
is
another
a-
job site.
it used to be.
That's what I was
We put string and 4 foot string,
That's what I was
explain it to the time.
That's what I was getting ready to say,
It's not
yeah.
just protractors on your compasses, you can do it, if they have the idea, we can do it.
On the baseball field, when you set those bases.
Yes.
Yeah.
When you put the fence in out there, my father-in-law does the fence around baseball fields.
Mhm.
And I don't wanna be anti-technology either, but I do think that for some people, including even modern children, you know, it's good for them to have things be more physical than what's on their computer screen.
I agree.
I mean, and so I don't think, you know,
The-
the idea that math is gonna be all on computers, I think is, that's not a world that I wanna do anything to promote, so.
But there are times when the technology makes some things you wanna look at much more efficient.
Yes, and I totally get that, I mean, yes,
Because I've done some constructions with compass that are pretty steep.
yes, and
They're hard.
I don't want, I don't want people spending hours doing things, but my only point was that, you know, for some kids, they're just not ready to look at a computer screen and see something that they can
They
see
need to physically do it.
in their own hands,
And you know why I suggested or was not just financial considerations, but some students don't have fine motor skills
Right.
developed.
So
But they
this is great.
still need to see what happens when something is drawn or constructed, so I just worry about those kids.
Me too.
So options,
Yeah.
Yeah, and I like preface even
My
more.
my teenage son, and his fine motor skills are great.
Most of mine, every once in a while you get one of those kids that just can hardly write their names, you know, that they have to.
It's very awesome.
Well, and then there's Bob. All right, so we're on to number 6. See how I'm trying to get us through this cap?
Enthusiasm, there you go.
I think we just kind of.
Yeah, we
Kind of
talked
took
about
care of
those.
that.
The only thing that we didn't talk about was tessellations.
Yeah.
How important is tessellations in middle school? It's a fun little project.
It's a nice application.
It is.
It is, but yeah, I think it should be untested for sure,
I mean, does it
So
even
do
need to
we
be
just-
standard?
you know,
Well, it's an EG, you can drop it.
let's do it.
That's true, it is an EG.
You know what EG means, drop?
That's what it does
If
now.
the district wants to use tessellations for that, then
Right,
that's
that's their
wonderful.
option to use
Yeah, I-
tessellations through which to do that. And I think what you find anymore is a lot of art teachers, I mean, tessellations are used a great deal in art classes.
Yeah, oh yeah,
that they're
it is a
so-
nice connection to art. And
And that could be something where we talk about tessellations and carry that over there. We'll do our, you know, do our math class, but this is really something that,
it's actually an area of mathematics that was not developed until an artist developed it.
right,
Escher's the one who
Escher.
developed the mathematics of that, and he was not a mathematician.
Yeah.
So. My art majors always get excited when we talk about tessellations.
There's an excellent video of how to do each of the methods. But it's a big interest.
okay, we're looking at number 7 then, so 6, we said we've already pretty much covered. Okay.
Seven seems kind of elementary to me to be here. It's,
I think so too.
at most 6th grade, so they're identifying whether it's a prism or a pyramid or whatever, but I just really,
We've already talked about surface area, haven't we?
in 6th grade,
So why would we not identify
so,
one?
so at most, maybe we'll throw that in 6th grade or fit it in somewhere, but I don't really,
6th grade or below, because I would be, and talking with the 5th grade
Okay,
teachers,
so-
what they're gonna do with 5th grade.
less standard equals 6th grade.
Less than or equal to 6th grade.
Sixth grade does volume,
Yes,
so it fits there.
2 minutes in there, yeah.
And then, let's see,
2,
8 goes back to the nets.
And sixth grade, huh? Eighth, no, sixth grade was next with volume.
But it also has, Massachusetts, it has projections and
In
it has
perspective drawings.
And I don't know, do we need those?
It's like isometric, do we need isometric
Yeah.
drawings?
Do we need the isometric things? And then
Because it's in the current standards, or isn't it?
No,
It was in
It was in
GLEs,
GLE.
it was in
It was in
GLEs,
I don't think
GLE.
it's-
I think it's in the-
Yeah.
That was one thing they applauded. for
because we
Common
did teach it last year because we were still doing.
I don't think
Right.
we need it, but I don't know. I mean, it's,
Does anybody's, I mean,
That's another one that Wesley said was about dentistry.
I said, well, how many
we
teeth
were
are
actually
you gonna
talking
have?
about-
Every teacher
Well,
has
it's
a
a lot
lot
of
to teach,
teachers.
had to
Yeah,
figure
we
out
talked
what
about that.
moments where I teach ourselves before we teach the group.
So I would like to keep it.
I don't know that it's an 8th grade thing.
What's that?
There's great application.
Is that something
for it.
for you?
Architecture and like, you know,
Yes,
a
I
lot
can
of
see.
careers you need, and a
Yeah.
lot of careers are going to solid, so you can
Yes.
spin it however you want to, but isometric's always one of your set views
Yes,
you can go to.
But do all middle
Well,
school
but-
students need that?
yeah, I was gonna say, is this in middle
Oh,
school or is
middle
it
school.
something that high school? And I think that's something maybe that we need to address, that as we get into high school, that will say, okay, this is something that needs to be done, is it middle school or high school?
It's very hard for them to spatially visualize it in middle school.
We have to build the blocks on, we have to get the blocks out, put it on dot paper, and then they have to translate that onto their dot paper, and it's still, especially for your lower kids that can't think abstractly, it is so difficult for them to get it from one to the other.
So-
Well, what do you think about maybe not them drawing it, but them identifying a,
views.
yes, identifying a, so that we're getting some of it in.
From a map plan or from a,
Even perspective drawing, and that come in, go back and forth.
They can do it from a given math plan, and if they're given an isometric drawing, they can put that into a math plan. It's just, if you give them a drawing, or if you give them a math plan and have them draw the isometric,
Mhm.
then they struggle a lot.
So they're still getting the
So
isometric
they
view
can
in the head.
recognize it,
Okay.
Right.
they
Something,
can
yeah,
recognize
because
it,
middle
it's right,
school,
left,
they're
and
getting that concept in.
Just recognize, not draw.
Yeah.
Yeah,
So, no, that they would
that's
not
my
draw.
question. Is it something though that we're just kind of throwing in because we've been trying to connect everything, or is
Right.
it something important
that
that
they
we need to put in?
In the past, it's always been kind of it doesn't really fit anywhere, but here's
Right.
this.
Yeah.
Yeah,
Should it be that way? No. Is it the way that it ends up in the classroom with every teacher that I've ever taught with? Yes.
Well, is
My
this come
kids
back in
love
trig?
My kids like
Wouldn't
it
be in
if
shred.
they picked up on it.
it wouldn't end up in trig, it would probably, it might end up in geometry
Geometry.
or pre-calculus, but it would not be in a trig class. Not in trig,
Where
you
would
might
it
have a
come
math analysis class, could very likely be there.
Where,
Then
how-
again,
what
that's
way?
not, there's a lot of things that's gonna miss if we're talking about.
I'm not seeing where it comes up, where would it come up again at all?
Well, I said it might come up in some of the pre-cal, I taught in pre-cal, so
I'm
it is
just
there.
saying, do we want to do it to help those kids that are going into career even more than college, right?
That would be the reason, because
Right.
I just don't see, I mean, it's kind of like its own thing.
Mhm.
But
I
they
don't
do
see it.
tend to get it in art also, along with tests. I mean, they
Perspective
do
drawings
the
are-
perspective drawings a lot in art, not totally tied to isometric, but it's introduced.
So how many people think this is important for a middle school child?
Are we talking about drawing it or just be able to match up the different purposes?
I'm talking about matching at this
Okay.
point, but to have some introduction to connecting that plan to, because I think that's an important skill for a kid to have.
Yes.
I don't know if it's an important to be in the mathematics classroom or not, but it's an important skill for them to know how to go from a plan to what it's gonna look like three-dimensionally. So that's why I think they put it in the nets, but
Do we still have high school drafting classes or those not?
No, those are. But the thing is we can't, I mean, is it important for all kids? I think that's the discussion.
Right.
Because not every kid takes drafting and not
No,
every
that's
kid
my
takes
point
art.
being,
Yeah.
if you're only thinking career ready, because that's the
Right.
application for this, then drafting would cover those kids who are interested in that
Right.
kind of career, so you don't have to worry about covering it now.
But you have diagrams for all kinds of products and
Right.
not just people drawing, but people having to
Simple.
assemble, read something and figure out how you're supposed to work this,
That's true.
whatever. They need to be able to go from a two-dimensional picture, what you don't know, they need to be able to recognize going from a two-dimensional picture to a three-dimensional
That's
object,
true.
to be able to do something.
Yeah,
so I
that's
think it's
true.
a good skill. Is it something?
Exactly, I don't have the answer to that, but I think it's a very good skill.
So do we want it in math class, math curriculum in middle school?
Can we put a question on it? Because it seems like, I mean, I think we're in the mode of shrinking and not expanding.
Okay, so I included
That's
nets,
my
nets, part of it is going to sixth grade, because we already said that. And then I put a big circle around projections
In perspective.
and perspective drawings, question mark.
And whether that stays in middle school, high school, or school.
Oh my gosh, we're down to measurement almost.
Measurement day.
Oh, measurement.
I know. That the measurement day, we got two more.
So excited.
just get to it.
So okay, so measurement.
So I look at all these things and, you've got to do it before ninth grade if we want to beat science. Do it and do it our way. I'm talking about for the conversions 1 and 2. But really, this just goes with the ratios and the
Yes.
equations.
That's what we said.
Three, four,
That's, I
five,
thought
we've
we
already
already
done.
mentioned
Yeah.
that in sixth grade.
That's sixth grade.
So I think this is sixth grade because I think we've already kind of seen this. This was already in sixth grade before.
Now, I do think it's kind of important to word it kind of like they did, given the formulas convert from one system to another, just to get teachers thinking about when you substitute, when you're working with substitution with those variables, that you also put them into existing formulas to manipulate. But I don't know if that's sixth grade, because I thought we were doing one. did we do
Well, I think
third?
one is definitely in sixth grade item.
I agree.
Two, I'm not sure, convert from one system to another.
I think
When
two
they
would be, but two definitely needs the formulas, or needs
Oh,
the
absolutely.
Yeah,
conversion rate.
Agree.
I totally agree with that. I'm not sure, I don't know if I would put it in sixth grade,
Or seventh.
or, yes, but one, I think definitely can move to sixth grade, because I think we already talked about that.
Okay, so one in sixth and two in seventh, because it may be decimals or fractionals or.
Yeah, and it, to me, follows with what Julie said, the ratios and proportional reasoning, that we can use that right
And
there.
that's a very good point, is that it might have fractions and decimals
Yeah.
and things like that in it.
Yeah, absolutely.
Okay,
And the example that went with one that we put in sixth grade was within the metric system, which is very easy.
Mhm.
But within, the same system, well, I guess the English system, as long as you stay within that same system, I guess it's okay. But then two is going from
Yeah.
one system to another, and so you are gonna have more sophisticated numbers, so maybe that's not sixth grade. But I think it should be seventh.
Yeah, I agree.
And then, unless, because we wanna make sure that we've got the right balance between what we're doing in seventh and what we're doing in eighth.
If we write a standard that says we're only gonna use metric without changes, is that legislative? That's what makes it really hard for
Yeah,
us in this
yeah, it is.
country, is we're always teaching two systems all
Yeah.
of us.
That's why I think it's traditionally throughout the United
We are.
States that measurement is always by
Yeah,
far
we're
the
really
most
bad at
categories in
measurement.
testing.
okay, three. Area and perimeter we've covered,
Mhm.
circumference of parallelograms.
Circumference.
That's
Parallelograms.
because they're saying perimeter circumference of parallelograms, that's what it is. It is.
Why don't we just ban the word circumference?
They
Registered
also,
to say there.
say, given the formulas, so here's a big difference between our current standards and this one. This one says, given the formulas, find your surface area and your volume, which we had in sixth grade, like rectangular prisms.
Let's see,
But then cylinders and spheres, I think, is currently in eighth grade.
But these are also 2000s.
That's
yes.
And they also don't have cones in here, do they?
No.
true.
Archimedes would turn over in his grave.
And
Oh,
I
boy.
think, doesn't it say no to formulas?
Yes.
Yes.
So there's a big difference, and I think we as a group would have to decide which ones of those paths that we would be on. One is given the formulas, and the other one is they need to know the formulas.
Okay, so let's dissect this little part. We've got the area and perimeter of parallelograms, trapezoids in sort of sixth grade, because they're composing and, I should say decomposing shapes,
Right.
Right.
correct?
Yeah.
So we see this part is sixth grade, we see the circumference of the of the circles, and the area in seventh grade,
Yes.
Of circles.
circles.
I think so.
Yes.
Okay. And then the volume, well, the surface area we have and volume of rectangular prisms, we
That
have in
was sixth grade.
sixth grade.
Right.
I'm making sure I write this. And then if we go to, I think we should include cones.
Yeah. Right circular cones.
And we don't have pyramids, right?
And there's pyramids are also in the current standards.
Those are not even current.
Pyramids are?
Pyramids
Cones are about.
Prisms. And then cylinders.
And then the other difference is it says know the formulas for volumes of cones, cylinders, and spheres, and use them to solve real world and mathematical problems.
For volume, you said?
Yes.
Yes. Cones, cylinders, and spheres.
So should we clarify then that what we're gonna do, or our suggestion, recommendation is that we're already doing, area and perimeter of parallelograms and trapezoids in sixth grade, correct? So we're taking it out of there. Circles, area, and circumference, in seventh grade. And then, surface area and volume of rectangular prisms, where it's already a sixth grade item, correct? Okay, and then So we're gonna determine surface area and volume of cylinders, spheres, and right circular cones in seventh grade or eighth grade? Eighth grade.
Well, if you're using an irrational number, it needs to be eighth grade, right?
Okay, so surface area and volume of cylinders, spheres, and right circular cones in eighth grade.
And what about pyramids?
No,
Huh?
No.
No, I mean, where are we putting pyramids? We're not doing high school? Really?
I think that we could do surface area in sixth grade because it's made
Yes,
up of
that's what I was thinking.
triangles and, yeah,
So why would you put volume of a pyramid in high school?
because Tiffany doesn't want to do it.
It's
But I
all
mean-
about what I want.
But I mean, if you develop a relationship between a cone and a cylinder, why not go ahead and do a pyramid with a prism? It's the same relationship.
And that's what I was thinking, I think of cones and pyramids together.
If I was gonna move one, I don't, I say we should, it'd be the
Sphere.
sphere, that's the hard one.
Yeah, I agree with that.
But I'm not saying we should, I'm just saying that. would be one.
Currently, we used to find, with GLEs, we found the surface area of a cone. And spheres, we didn't do volume.
Yeah.
Now, currently, it has no formulas of volume, for volume of cones, cylinders, and spheres, but it does not have surface area of cylinders.
Really? Of cylinders? That's crazy.
Yeah.
That's an easy
So I'm
one.
not saying that we can't, I'm not saying that it can't be in there or anything
Yeah,
like
the
that.
surface area of the sphere, I would understand.
Right.
But
Surface area of a cylinder.
cylinder is in that.
Yeah.
I mean, once you know area of a circle.
I know, and you know that when you make your net, you have to be very cautious with middle school children, how you make
Yes,
that
I'm
net.
sure you do.
Just like throw that out there.
I see that, yes.
And your circle should not be on the same end. Yeah.
Couple of those things.
You have to think about things.
I have to go back to this.
Yeah.
But, you say it's easy, but they had a really difficult time. They get the length and width of a rectangle, but they have a very difficult time determining the length of the rectangle as it wraps around the circle.
And Bob, I will even,
Yeah.
in my calculus students struggled with that as well. So, even though they didn't develop it in middle school, but when we did it in high school, and they had to develop it by the time they got to me in calculus, they still really, and it was amazing to me that they really
Okay.
struggled with that.
That is a very common thing.
Cut the
You
labels-
can't see, yeah,
have a
and we've
canned
done
food
that.
drive and cut the labels off.
Yeah,
You know,
We've
if
done that.
we're going narrower and deeper, maybe,
I mean,
They can follow the formula, but when it comes to even, because we did that, we brought in cans, we tore off the labels, we measured it, we took that string and wrapped it.
I quite understand
They
that.
had a really hard time with that. We even took
Okay,
string and
so we're doing volume of all y'all. Is that correct?
Volume of what?
all
of them. And surface area of everything but spheres and cylinders?
I guess
we're not doing surface area.
Okay,
I mean,
So-
it's not, it's,
that's a hard one.
it's
Yeah.
How
not.
about surface area?
No,
No.
is that,
I mean, if you wanna go by hard, cause you're talking about, that's hard, you gotta knock sphere out completely. Cause I mean, we do it
never-
with Play-Doh, but it's, it's not an exact thing,
Yeah, are you talking volume or surface area?
either one.
Either one.
surface
area
areas
is volume,
really
this is the
hard.
first year, I've never taught that to eighth grade yet, so
Okay,
I
so
don't know how that works.
Sphere would be high school if you're going by that. Cone, in terms of surface area is really hard, cause you gotta do the
It's not
center of a
listed.
circle.
it's
Yeah.
not.
It's not here currently though.
yeah, I think that if we're doing this, if you look back at sixth grade, it says determine surface area and volume of three-dimensional shapes, and this is in the introduction, okay? For things composed of polygonal shapes or, so it gives you the freedom to kind of expand that to a pyramid or to you know, whatever you're going to use there, because it has triangles and I think it specifically says,
Prisms and pyramids.
It does say
Student-size
surface area
Yeah.
prisms and pyramids under the critical focus area,
yes.
I guess,
but not as a standard.
it seems to me like,
Because it says you can compose them.
Right.
it seems to me like, yeah, surface area, I think you could do surface area and not do any formulas at all.
But you couldn't do the cylinder until at least 7th grade when you get to surface.
Right, but what I'm saying is, I don't believe surface area has to be done with formulas.
At all.
You just find the area of all the faces.
Yes.
And so I think formulas, to me, are not important with surface area.
Yeah.
Volume, though, there's such nice relationships, it seems like you're missing something if you don't do that. You know,
Does it need to be at 6th and 7th grade level, or is that something formalized more when you get to?
I mean, it's been there for some time, some of them at least.
Well, we said they were gonna warn me when we were at 10 minutes.
It is.
Okay, and it's about 10 minutes before, so do we want to try to finish, and I'll just let the group decide, do we wanna finish geometry this morning, or this afternoon? And then, excuse me, measurement. Finish measurement this afternoon, and then reconvene in the morning and try to get data done first thing?
I'd like to take about 3 minutes and do that stuff and finish up and take about 5 minutes and finish this whole thing.
I think we're done with geometry except for 3, aren't we? I mean measurement, I'm sorry, I'm saying geometry, because it is geometry. I mean 4 and 5 we've done, haven't we?
The only thing specifically velocity and
This is-
density. But that's after EG,
Yeah,
so we're
that's an
scratching
EG.
that out.
I was wondering what you did.
I just think
Easy, stop it.
the main difference, I mean, finding volume, okay, the main difference that we need to know and that I need to know as a teacher, do I give them the formulas and they know how to plug and chug? Or do they have to know the formulas, have them memorized, and then they
Yeah.
plug and chug?
Tell me real
That's a
world.
very important distinction.
I think most, I mean, if it's you can answer too, but I think if it's, some careers, you use the same shape over and over and over again, and usually if you don't know it, they have all sorts of flip books and charts they go look at if it's one they don't know. So I don't have a problem with the reference sheet, but I know there's a few employment tests, but it's usually just like your basic areas, it's not something crazy that I don't know what you see.
Yeah, I'd say the same thing. Things that you don't use very often, you look them up. That's how you look in the real world. Things you use all the time, you know.
I don't think we give them formulas.
I would, this is the high school teacher teaching me, I would prefer them not be given formula, that what I really wanna see in middle school personally is that they develop those relationships, they develop the understanding that I know how to break the faces apart, I know how to do those things to be able to find the surface area, rather than memorize, giving kids a formula and finding it. I want them to conceptually really understand, because when you get to calculus, when you get to some other ideas, I want them to understand those concepts.
I totally understand that with surface area.
In
I'm talking
that-
about
in that-
volume, though.
Well,
In
for
that
volume,
case, you have to take sphere out, because
Yes.
there's
I
no
agree,
way
there's
to.
no way to do that.
No.
I wonder, are we begging the question, how is this gonna be tested? I mean, is that the question we're really sort of dancing around? Are kids gonna be given the formulas and do
Yeah.
they need to know what to do with them? Or is this just something we want them to explore? And I think it's the latter, but how do we articulate that? Is
Well,
that-
and I love the idea of not giving formulas for surface areas, and I agree with you, it makes more sense, because those kids don't memorize, I mean, even if they try to memorize them, they memorize them incorrectly, so they're
And
better
they
off
apply
to
the
just know
formulas
the,
incorrectly.
right, they're better off to just know the process, but with volume, like volume of a cone,
But if you work off of cylinder, it's the area of the base times the height, which is the same for a
Right.
prism.
Yes,
Right.
And then,
the third.
I mean,
then
well,
it's
and
just
that's
their
then where
The
I
pyramid's the same thing.
would put pyramid in instead and take the sphere out.
Yes,
Right.
I think that's probably good.
to be
But
volume
then
of
back to
those
her,
cylinders.
back to her question, do they get a formula for the cone and the pyramid, or do they just?
No.
supposed to
No,
remember?
I think
Okay.
that's,
I don't think
no, I mean,
They're all
if we take
related.
this.
No,
sphere
no,
out-
relationship,
Yeah.
making some
I
relationship.
just
Yeah.
think it's a distinction that needs to be in there one way or the other.
Okay.
What it needs to be is know the
Yeah,
formula.
So I have 6th grade are prisms and, pyramids for surface area. Okay? I have 7th grade, we're adding cylinders in there.
For surface area.
For surface area.
And volume.
And volume they can,
Yeah.
because they'll know the circle, and so they can build up from that. And in 8th grade, we're adding the volume of pyramids and cones, is that correct?
No,
She added
cones
that
and, volume of cylinders. That's fine.
I don't care whether.
Where are
they're
circles?
7,
That's what she was saying.
Yeah, that's why you have to put it.
and we could move it all to 8th grade so it's all together and you can see that. So we could just move all that stuff to 8th grade. Why don't we lay it out, see how much is it needs.
Yeah.
Yeah, because I think most
Keep it
8th grade
balanced.
teachers would bring up that
Yes.
as a segment.
kinda like
to
it.
now
Cones.
two more.
Yeah, I kind of like it together in some respects, you know, in 8th
Yeah.
grade, 6th grade.
So,
Okay,
do
Ken,
we want to,
get your stuff.
do we want, okay, so, and then tomorrow morning, these are the few things, and then we'll see, we'll talk about if we can finish this up, if we wanna stay and finish it up, or we wanna leave. What I need to know is, these are a list of supplies, and I'll just say the things that we need. We've already got, I think, pencil boxes of supplies, pencils, sticky notes, and markers, we've already brought our own, so I think we're fine with that. Name tags, do we need name tags, do we want name tags tomorrow, I'll take prints? Just a blank name tag, put them on again tomorrow, or yes or no? I'll just say yes, okay. Poster paper, I think in case we did it, that probably having poster paper here is a good thing. Computers and bags, I think we brought our own. Web cameras, I think we don't need it. Projector, will we need a projector?
I have one in the car.
If we need it. Okay, clickers, no, I don't think so. Power strips,
Yeah.
power strips. Okay, we'll say 2 to 3 because of this room, there's not very many, I'm guessing. What about an extension cord? I didn't see that down on the
Also,
list.
you can do more of those things
Got
that you
one.
have down
Well,
there.
that-
Or you can
okay.
plug into one of those.
Yeah, so power strips plus extension cords. Okay, speakers, no, we don't need those. Lunch days, yes. Sign-in sheets, probably need a sign-in sheet, so just set for official records, you know who's here. Rolling cart?
Yes, we do.
Okay. Yeah, because you have to bring it over, okay. Are there any documents that we need to have tomorrow?
Printed.
Yeah, what they want to know is anything printed.
How about, new people, we had, some documents printed, were there things that you
The higher
wanted,
ed
like,
document.
The higher ed documents.
Massachusetts saying the supplement so that you have your own copy, or, okay, would you like your own copy?
There were some, I think, left maybe the higher ed the last time, because there was a lot in there.
If we're gonna look at the ACT document, do we want it?
The ACT standards,
Yeah.
yeah, probably, I've got a copy, I don't need it, but so ACT, that's the higher ed. And there's several of those, but I don't think there's another Massachusetts document. Oh, yeah, there's one.
Yeah.
So what I think higher ed we're fine. Of course, and I think higher ed we're probably okay. What about, do we want ACT, college and career readiness?
Did we find out if everyone got the Massachusetts, you want Massachusetts?
Right, I think
You
we
have
have
it,
copies.
you have the ACT on Dropbox, right?
Yeah,
I don't
ACT.
need to take a copy, so.
We need
She
it
wants
in
Massachusetts.
Okay, so Massachusetts document.
I'll take, ACT though.
Okay.
I would too.
Okay, how many would like the ACT document? 1, 2, 3, 4, 5, 6, 7, 8. And we probably should get a couple more for, I don't know, Fred and a couple others too. So should I say maybe 12 that we could have that as a plan? Okay, Massachusetts document. 1 copy and ACT. We'll say 12 copies. Okay, room reservations were here. So that was pretty much it. So Karen, are you taking that back? Okay, good. And the Massachusetts document, maybe we can, who do we send that to? Because I think we have it in our Dropbox, we could just. Well,
I got it.
if she has it, then we could just take it back and make a copy, or if you wanna keep it for that, then we need another copy of that one, okay? And ACT standards, we've got in our Dropbox folder, I think we can email those to her, that's pretty short. Okay, so that was the housekeeping that we needed to get done for this. Here's my question, it's like, it's 4 o'clock. So do we want to adjourn, or do we wanna try to finish this and then move.
I'd love to finish 8th grade, but I have one more geometry.
Well, do we wanna, and because I know some people are driving home.
Yeah.
So, and some people drove in some really nasty weather here, so do we want to do the geometry and adjourn, or do you wanna just try to finish 8th grade and be done?
I
What's,
have to go, but I don't, it's totally fine with me if you guys want to.
because we still have a quorum here,
I just.
okay?
I
Yeah,
think the
that's-
data's small.
Yeah, okay. Okay, so we'll go ahead and finish 8th grade and let's get 8th grade done, and then we can take 2 minutes and talk about what we're doing in the morning.
The only thing that I wanna say is that in our current standards, there's something about, talking about the when you slice a 3-dimensional, what 2-dimensional shape. And I think that is important for, it's as close as we're gonna get to those kids visualizing what's happening with those things. I would like to see that remain as part.
Yeah, I think that is important, yeah.
And that was, 7G3 took me out
Thank
to.
you.
Community representation of community objects.
Yes, I knew I'd seen it somewhere, I just couldn't remember.
Is that okay with everyone?
Yes.
Yeah, I think so. Okay.
When they cut a 3-dimensional shape, what 2-dimensional shape
Just
can
look
you get
It's in the
from it?
Common Core, she said.
It's in the Common Core, it's not in Massachusetts.
7G3.
And
I know I did.
I think it's kind of important for kids to know that.
Oh, I agree.
I think it is, and that's, sometimes kids have a difficult time knowing what slice, when we're trying to slice it, what does it look like, so I think that's important piece. Data.
So, I'm sorry, what was the number in common core? We just-
7G3.
And it's on page
70.
It's on page 50, second one up.
I thought that related real well to the career stuff.
Okay, so just the cross sections of 3D also.
Now, for those of you who don't know, there's 2 things that you don't teach or that are holding to Rob, besides what they're only doing. One is he has a romance with Archimedes. Okay, we don't ever disparage him. We can tell you wild stories about him.
Yeah.
And the second one is
Yes, Dave's the data man.
Hey.
That's because he can use it however he wants. To say whatever he wants.
And he's pretty good at it. In 6th grade, we talked about the kids were kind of sampling
Right,
and displaying data
Right.
and interpreting it, correct?
yes.
7th
With
grade,
the focus on variability.
Mhm.
yes, sir. So,
He just wants to make sure.
when he teaches it, that's when he makes kids take oaths, don't you, Bob? About variability. He's a little crazy about it.
Didn't you do that, didn't you do that in math academy too?
Oh, yeah.
School teachers, I thought you, I remember you doing that.
Okay, so we haven't picked up on the probability that we left behind in Massachusetts. We need to pick it up for 7th grade, I think. Remember those 6th grade probability notes? We said we were gonna defer to 7th grade, and I don't wanna leave them out.
And that's in Common Core, that's 7GP, or 7SP, I guess, 7SP.
Well, and then
Number
he,
5. And 7, I think. Uh, Yeah, I mean, it was in Massachusetts in 6, but it wasn't nearly as explanatory or not explanatory, but as deep as what's here. I mean, they go into lots of different things about probability, compound events, and
Are you looking at 7th grade or?
I'm looking at 8th grade right now.
In 7th
I mean,
grade,
7th grade, 7th grade.
Well, but if you look at the 8th grade standards for Massachusetts, like we talked tree diagrams, tables, organized lists, basic common core, it's area models, compute probabilities for simple compound events.
Yeah.
So it's kind of a combination, the 7th grade is kind of a combination of Massachusetts, what we didn't do for Massachusetts in 6th grade, and the 8th grade standard here.
This is a big shift to what GLE is doing,
Oh, yeah,
because probability was very minimal in 7th grade.
right, yeah.
and Kathy Ashley in the 7th grade in the
Oh,
supplement,
yes.
it says use tree diagrams, tables, organized lists, area models to compute probabilities for simple compound events, and then has the EG, which we know we ignore. But, it does sort of put that probability in seventh grade, even though it's seventh, eighth grade there.
What's missing though in Massachusetts is what's in the Common Core in eighth grade, and that is all the modeling stuff.
Yes.
The regression is not there at all in Massachusetts. I mean, they talk about linear models throughout the algebra, but it's not the way it is in the Common Core. I think that's important.
So if you,
Yeah, no, do you know, is it in the Minnesota standards? Have they done it a little better?
I can look, I'll look, I have a copy of
I
that.
mean, I think part of the reason it's not in here is because this was 14 years ago. And
Exactly, I think so.
statistics wasn't out in the forefront as much as it is today.
I would agree with you on that.
And they've
Makes
updated
sense.
their standards knowing that,
Yeah.
there were some areas.
And I think what's in the seventh and eighth grade Common Core is very good description of the probability theory part in seventh grade and the modeling part in eighth grade. I think it's,
And I really like in seventh grade, the connection between experimental and theoretical,
Yes.
because they don't think about it that way. They don't
Because-
know, well, it's the fourth time, and this has already happened, so this is gonna happen. Okay, that's what should happen.
so if we think about sixth grade as what we said, the kind of sampling and then displaying and analyzing both centers of, measures of center and variability, okay, kind of put that aside. And then seventh grade, we're talking about the probability, and I think that just almost all of the probability is here, the central, the compound, the theoretical, the experimental.
Yep.
Are you guys intact with that? And I do think it's very, very bare bones in Massachusetts, but explained a little better in the other document. Is that okay if we kind of
Doesn't
move that way?
matter.
And then, what about, the other thing that was in there is, comparing the samplings of two populations and those types of things, that's also in seventh grade.
The inference is about population comparison.
yeah, we're talking about it in Common Core.
Yes.
Yeah.
Oh, Hulu.
So that would really essentially be saying it's 1 through 400 probability, or under that statistics.
Yeah, I mean, you're talking about looking at differences in measure center, and you're looking at two sets. I mean, to me, that's just amplification of what you did in sixth grade, because you wanna see two sets of data that have the same measure of center. You know, the means are the same, they're completely the same, no, because they have very different variability.
Right.
So that's kind of what I was talking about, even in sixth grade, but I think in seventh grade, yeah, I think that's important. You're talking about 7, SP 3 and 4.
Yeah, so I guess what I'm saying is, are there parts of the Common Core, statistics and probability that you think should be cut out in seventh grade? Is there anything you want to omit? I think Massachusetts isn't delineated enough.
I think statistics is a big area in our work. I mean, we read so much about it, we hear so much about it, and it's often misunderstood. So if we can do a little bit more to build the understanding or build the foundation.
The other thing is knowing what's in the high school. You see why you need this, because in the high school, they're gonna do a lot more with regression and residuals
Very
and
important to know.
stuff that hasn't been there before. And so,
That's why that's in. And I think in sometimes we may need to, looking at this, some clarification, because I think that some teachers, they'll read this and not really understand what it means. So, I think what's here is good. I think obviously some clarification probably needs to be made, because if you went and gave this or handed it to a seventh grade teacher and just saying, you understand this, and I imagine most of their answers would be.
Keeping in mind that most seventh grade teachers didn't really teach much probability at all.
right.
Yeah.
That's right.
So,
And it's
Just
really
like,
important.
I think what you're hinting at is like the sample on the population, is all that okay for seventh graders? I mean, can they?
No, I'm not saying the seventh grade students can't handle it, I'm just saying when she was talking about clarification to make sure that the teachers really know what it
Yeah.
means.
Yeah.
If the teachers haven't been teaching probability, they, who knows how long they've been out of college, it's been a long time, we're just like everybody else, if we don't use it, we lose it, and so, you know, sometimes when they look at this, or when we look at this even, because it's happened to me too, I'm like, okay, hang on, I'm not sure what that means, and I have to go look it up somewhere. And who knows if the source that I'm using to look it up is the most reputable one.
But once again, I think that it would be nice if we exemplified, I think that was a good thing from
Absolutely.
Massachusetts, if we showed examples.
Right.
I mean, the only thing that I see that if we wanted to make a change, it was talking about the inferences about the two populations.
What, can you put 50 bump?
Yeah, it's that 7SP 3 and 4 on page 50. I mean, in a sense, that could go in sixth grade. But I'm not sure you want to.
Do you know why I like it in seventh grade? I like it in seventh grade because we introduce in sixth grade and they get used to saying, okay, this is what it is. And then in seventh grade, they're doing a little bit more of the deep analysis of it and saying how they change. And so they're keeping it in their mind because we said before, they do something early and then you don't do it for several years and they go, we never did that. And, you know?
My teacher never taught me that.
I mean, there's enough in sixth grade. You don't need to add.
Yeah, I don't think sixth grade.
So we're okay sort of with
The concepts there.
SP, 7SP, as it is in.
And I really like that both of them are talking about using compound, using lists, tables, tree diagrams, and simulation, not talking about formulas. Because too often compound events, I know doing compound events in high school in algebra 2, they didn't get it until I started making the lists, the tables, the tree diagrams. Then they started to really see, because memorizing formulas is not what we should be about. It's going back and helping them understand what's taking place here.
Okay, so then we're on to eighth grade.
Go ahead.
Question, does your first year teacher know what combinatorics are?
Mine would, I mean, ours would, but
Okay.
our graduates would.
Okay.
Yeah, it is, it's kind of, they should. Okay, let's put it that way.
But I do think that we're going to have to explain a lot.
Because we're gonna have to have, we're gonna have to have a glossary with those terms, anything that we might think might be read, and that's where you, in the past, when we've done and sending out what words that don't you understand, then you can clarify, rewrite, make the glossary, make sure that's clear and evident.
Not that we make this
Well, I
last
should say something else about that.
clear.
Math, people have been trying to teach math should be done. But the
Yes.
career ed people, they have to look through whatever it is and they have to pull out and apply to their
Well,
vocabulary.
And bringing up, a really point that we need to talk about too is the number of people that are teaching math that are not certified to teach math. And so that's a whole nother issue. We have a large, they're not as large as some other places do, but we have a pretty good sized population that are not certified.
Those who are special education teachers,
Yeah, absolutely.
who have to be masters of all of it.
Elementary
Yes.
teachers that teach sixth grade.
Yes.
So
Exactly.
I think it's great that we're pointing out things like that. and making
Absolutely.
sure that we.
Absolutely.
Okay,
Because
eighth
sometimes we
grade.
overlook that.
The nice thing about the stuff in eighth grade is a lot of it is going to review, bolster the things we talked about with other functions. A lot of similar stuff there. So,
Are you looking at the Common Core document?
yeah,
Massachusetts?
I mean, I'm looking at both things.
Well, and I do like some of those things, but Bob, can you go back on the grade 7, the 8C, or sorry,
What is
Seven.
it? Grade 7, 8C.
but then,
Yeah.
statistics about those 8C, it's the very last things.
Mhm.
And, I don't have a problem with 8. Or A or B. And I don't necessarily have a problem with C, but I think some other people will have problems figuring out how to.
So do you think that that needs to be clarified?
I don't know if it needs to be there at all, but
Well, I mean, it's just, it's got tools to look at probabilities of compound events, list tables, tree diagrams, and simulations.
I think is the key to design
well,
or use simulation?
design and use simulation to generate frequencies for compound events. And maybe it's the example that I don't like.
Yeah, I don't like these.
I don't either.
No.
So,
But we do,
It's an
we do,
EG, just scratch it out.
for example, one of the things we do with my elementary teachers and middle school teachers is we do a simulation to look at, collecting data from something that we don't really have good data on. That would be like the birth policy in China, which
Yes.
they changed, but one time it was one child.
Right.
And what was happening was people were putting children up, girls up for adoption because they wanted males. So we look at what would happen if the policy where you get to have as many children as you want till you have your first boy. And we simulate that with
Floating points.
And we get really good data that shows the probabilities that you can figure out theoretically, and we do, but it's really clear when you do it, simulation. So that's an example.
I think designing the simulation's good for them, figure
Right.
out what quick way or easy way, cheap way, whatever represents this.
Yeah, I don't like that.
I don't like it.
We need to have some good examples.
Yeah.
Well, good catch.
So I think that we're kind of solid with that and probably kind of look at both documents for that. Now, one of the things we didn't do is look through all of the common core for the other things.
Yeah.
So I think if there's anything individual that we see, like, there's one specifically in there that I really don't like. We didn't, it's the slope one for the triangles, I just think it's too prescribed.
Yeah.
Well, don't you think it's too prescribed?
Yeah.
And I think it was just, to me, it reminded me of something that a group of people were sitting around and someone said, I have a great way of doing that, let's just
That
make it
is
as a
exactly-
standard for everyone in the whole
I
country.
agree.
I thought it was inane.
Yeah.
It's an okay way, it's not the only.
Exactly, and I don't think it was something that we had to tell everyone that they had to know.
Yeah, I would like to, since we went through Massachusetts and said what things we liked, what things we didn't like, I would like to go through, I know you referenced Common Core some, but I would like to go through and do kind of the same thing, because there's things in there that I don't like, and there's things in there that I really do like, and I don't wanna miss.
How about if we, are you open to this, that we kind of get the closure, because I know some people have some things to do, and that if there are specific things, then whoever wants those needs to bring those up tomorrow, rather than going through the whole
This
document.
is specific.
Yeah,
absolutely.
absolutely.
We've looked at a lot of them.
Specific title.
We looked at a lot, but I
Section
just
by
like, I
section.
don't want to leave something out if it's important, and it just didn't cross our mind.
Right.
Because we still haven't talked about where we are going to construct circle graphs.
Well, and the one thing that,
Not exactly.
I talked about this myself.
You did not make a decision what to do.
It's kind of a ritual.
and the other thing that they do bring up in here, and then again, it's just a representation, that you talk about Venn diagrams in the Massachusetts documents, and we've not talked about other forms of representation, so that's just something to keep in mind that,
That's
That is
something you
something
can
that's
certainly put in probability.
yes. I think that goes really nicely into what we talked about seventh grade, dealing with that. I think that goes, and so that should be something that we get recorded in here, because that is a nice thing to be able to use, nice tool. So, are we done for today? Does anybody, well, I guess we need to say we start at 8 in the morning, and I know there's some things we need to talk about first thing in the morning. So, does anybody want to move to adjourn?
Well, wait a minute,
Okay.
I think that we need to decide if people are going to attend Representative Barr's thing, then are we going to have a group here? Because some people said, do I want to be here if there's not going to be a quorum?
Well, and here's my question, do we think we can accomplish anything as a team from 8 to about 8:45? Because those people that would want to go would need to leave by 8:45, I would think, to be there at least. And do we think we can get some things accomplished between 8 and 8:45?
Maybe we could clean up the 7th, 8th grade stuff and get it.
Clean up the 7th and 8th grade
I mean,
things.
anyone who has an issue, bring it up, or kind of.
Right. Well, and if we don't, I think the other thing we could discuss and start discussing as a team when we start looking at the high school, are we gonna look at Algebra 1, Geometry, Algebra 2? Are we looking at being involved with integrated? There's a lot of issues that come up there that we could talk about in general. And then people that need to leave and go, and then whoever chooses to go, and I know Nancy, you're not gonna walk over there with your knee.
No, I'm not. I cannot.
You're not walking over there with your knee, that can sit and reflect and read through documents while people are gone, so. Cause I know there's no way you can walk over there to that. So,
But we definitely, I mean, if there's enough of us going, we have to adjourn because we want.
absolutely. Yeah, we won't
Oh,
have
yeah, no
one.
business, I don't
Right,
think she's saying
right.
business.
So, no,
Yeah.
that people can stay if they want to and reflect or do whatever they want to until everybody gets back to get started back up. So is that acceptable to everybody? Okay, so does anybody want to move to time and start with that? Make a motion, a second, okay, all those in favor? Julie second. Okay, all those that are opposed?
I'm gonna stay.
I'm looking at you. Anybody abstain? Woo-hoo,
I'm going to show you this though.
we're done.
Hey, Margaret, you know the grouping circles that you use for organ diagrams? They were $6.95, but they